We also recognize that this land is home to the Métis Nation of Alberta Region 3. At The Wave, we are dedicated to creating an environment where ideas can flourish and where the spirit of cooperation and creative ideas drive our collective progress, inspired by the enduring legacy of this land's First Peoples. I'd also like to remind you that if anything happens today, we have 3 emergency exits. The one is the door you came in. There's another further door through the loading dock, just through the big white doors there. And then past the washrooms, which are the little black arrows on the floor, will take you to the washrooms around the far corner. There's another door that'll take you into the back alley. We do have a muster point today, and it'll be on the northwest corner of Olympic Plaza. All right? We're just waiting for Nan, so before we get started, I just want to figure out how many city employees are here today. If you could raise your hand. Okay, great. What business unit are you from? Calgary Fire. Oh, what are you hoping to get out today?
I'm interested in the virtual reality.
Oh, it's not working today. What are you looking for today?
I'm looking to steal some good ideas.
They're free. They're free. And if you ask, Chase has got lots of opinions, and he gives those away for free. So don't worry about. Where else? Foma, you're from Infrastructure Services, and what brought you here today? All right. Okay. Well, we hope to have like a regular city day where people can drop in, see what's going on, collide with the other people that are working on experiments here. So who's from outside the city today? Lots of our Humber guys. Okay. What brought you today here, sir?
With the Canadian Standards Association.
Oops. No, it's good. Great. Great. So what are you hoping to get? Oh, is it the ATSC 3 stuff, or what are you looking at for today?
We're looking at AI, IoT, and if there's any standards needs or
Okay, yeah. I think like with standards, especially when it comes to some of the work that the ATSC3 project is doing on getting emergency messaging, what does a Canadian standard for cell phones and televisions look like? Is that something that could be explored? I'm totally winging that, but because I'm looking back there and they're not nodding their heads, so I might be out to lunch. But we have some phones in Canada that are ATSC enabled, which allow emergency messages to go to them. Cool. And besides, hey, you're from Rogers?
Rogers.
Yeah, right. And you're here for today. You're with the Rogers place is called
The Think Lab.
the Think Lab.
The innovation team. But I'm just excited to check out what the city's up to.
Yeah, good. All right, great. Chase, have you heard from Nan?
Just walked in.
Awesome. All right. Hey, Nan, how's it going? Grab a coffee, grab a water, and I will keep winging this for a bit.
Spit the chocolate.
So this is an experimentation center. So we are still moving in. We just started being here last week. So we're still working on lights and TV, and our DJ is a little bit. He's got to update his music files, so there's lots of just new stuff happening, and so if something isn't working, we're still beta. Forgive us. If our broadcast doesn't work, we're just trying this out, so forgive us. If the coffees are stale, no, it's good. The coffees are great. The buns are great. Sorry, the coffee's stale. The muffins are stale. Winging it. All right, and with that, Nan, are you ready to go?
Oh, thanks everyone. Good morning. Apologize again. As Jason mentioned, I think everything needs a little bit pilot. So this morning, the first snow need a little bit pilot for me to get here too. So, right. So I'd like to talk a little bit about, everybody able to hear me okay without microphone? Okay. Just talk a little bit about emerging technology. And first of all, this is exactly what IT is doing today for our citizens. We have some numbers here. 600, almost 500,000, more than 500,000 of the city users' IDs. We serve 17,000 our employees' devices, and all the 3,000 city vehicles, everything, these are all connected through IT. And we're here to provide services, and that's basically our North Star, to provide our services from IT, right? And always this fancy word about emerging technologies. So I'd like to basically define what exactly are emerging technology here. You can basically see AI, some of the AR, VR you have seen here, this tech center here, blockchain, and lots of these robotics stuff here. The reason I want to show this is basically for each of these technologies, we treat them a little bit differently because each technology has their life cycle and their maturity. So we cannot invest our limited resources in each technology equally. So our strategy is looking at, for example, that's why we have this beautiful tech center here to see what technology you can bring in at what point and what kind of resources you should invest and what kind of engagement we are with this type of technology, right? For example, it's quantum, with some of the blockchain. Basically, we're doing work with university, work with pilot stage here, and understand a bit more before we even jump in. But for AI, we know that although it's a hype, but AI, we does already see some of the return, some of the tangible use cases come in. So our focus will be a little bit different with blockchain and say quantum, right? Because that's how we treat things a little bit differently with different type of technology. So in the city of Calgary here, basically work with Monique's team and our other IT teams. What we're doing here is based on different technology, and also we have a little bit of process, say from testing the technologies, pilot technology, to basically bring it to our enterprise setup, to eventually put it into production. That's a life cycle as well. It's different phases, right? From getting the concept, understand it, and basically test it out here at the lab, understand the feasibility, then to the other team that are looking and say, hey, how can we bring the technology under the City of Calgary's cybersecurity framework, our technology framework, and then eventually roll out. And also, most importantly, is also understand, make sure that we can transfer the technology into our internal IT team and internal business unit teams. Understand that it's not just a technology outside. It's something that we can embed into our daily workspace. So it's actually a long process from here, this lab starting, to somebody use it at the field. And I always love to see this I call iceberg model. Use AI as an example, and this is not just for AI. From enterprise emerging technology stack, this is what we always see. The beautiful part is always above the surface is the application side. Let's say we have AI applications, pothole detection, or whatever, that's visible. And that's what most people see. But under the surface, typical is the AI models, right? And in the past, AI model is typical, is relatively difficult to build. You need data scientists, you need lots of expertise to build models, but that's no longer the case, right? Low-code, no-code models, open source, and lots of models. Things to understand, lots of these large language models are really available. So the tricky part right now for enterprise IT to do this type of work is focused on how we can identify the right data from our enterprise and how can we bring this data together. Where do we store it? So I know that our Dave Vigers, another IT manager here, is going to talk about the enterprise data strategy this afternoon. And that's a key component that without take this data piece out, this is going to collapse, right? And then the bottom line here, we have the enterprise infrastructures. So here we are in Azure shop, right? So on our Azure environment or other cloud environment, also potential could be city data center or could be a partner data center here in local. So that built our infrastructures. And I kind of draw a couple lines here. You can see security is something that always tie these pieces together from different stack, different layers. I would say legal and privacy. Legal, typically, we talk about those application layer. For example, if we roll out a chatbot facing external, citizen facing, basically we need to do lots of research from a legal and legislation perspective, right? And then privacy and access touch the enterprise data level and also the models, right? The transparency of the models, what kind of data we're using. When we put all these data together, would that create some privacy concern, right? So that's what we always look at, say, bring in a model to the city. It's different with doing a consumer or individual development. At home, I do this all the time, right? Download a model, put it on a machine, I get my AI done. I'm teaching my daughter doing that as well. But at the same time here, the city, enterprise things are completely different, right? If any questions, feel free to raise hand. We do have, I think we have 10, 15 minutes at the end for discussion as well, right? So first of all, I would like to share a bit about our, we talk about IoT. And here our focus is industrial IoT, right? We call IIoT. And I want to highlight a little bit about our LoRaWAN network, the long-range low-power network. So I'm not sure how many of you are familiar with LoRaWAN network. Raise hand. Excellent. Oh, I feel that I'm in the right place here today. Thank you. These are basically the network that are able to support battery power sensors. And you might ask, why do we need battery power? And that's because we might not necessarily be able to find fixed power everywhere, especially in large cities, right? So the battery power sensors last years of operations actually give us advantage that we can deploy sensors in almost wherever we want. And last years, we don't have to replace them. So that gives us an advantage, say, hey, let's use these solutions and collect all the data for us for future data, machine learning, et cetera. So Citi has a city-wide covered LoRaWAN network, which is basically, I'm going to talk a little bit about, not just for our internal business users, also open to our local communities, startup companies, researchers through our Living Lab programs. So that's basically the LoRaWAN network that right now we're sitting here. If you have a LoRaWAN devices, you should be able to see or able to connect to our network through some, of course, some approval process going on, right? So the coverage is quite big for the city-wise. That's our LoRaWAN network I want to mention. Some of the use cases I want to highlight here is that, for example, this is the use case for urban heat. So every summer, in certain hot spots across the downtown areas, there's urban heat problems. We could basically understand these problems through satellites, but those are the resolution-wise and the update frequency is not as good as you put a sensor right at the spot there, right? So that's why I deployed some of the LoRaWAN urban heat sensors with our business partner, I think with our climate team, to understand each spot, say, what caused these urban heats model, these islands, and what can we do to might be able to change some of these, say, can we plant more trees? Can we build more buildings? Is the shadows help, or does the trees or whatever the structure is gonna help, right? And potentially, if we can merge this with some of the cool AR, VR setup here with Chase, right? Then we'll probably understand that, hey, how does this heat model demonstrate in a 3D way? How does it look like, plus sound, everything? So the conversion of IoT, AR, VR, definitely gonna give us a little bit more head, say, hey, now I understand better about our environment and ambient, right? So these are the studies that, thanks to our business partner from the environmental team, they've done a really good job and kind of see the value of putting these sensors there, right? I always love to see this and see I think Colin is our lead engineer for IoT. He done lots of these work. And you see the reason why we want to monitor, say, when and how we should collect our garbage. Instead of we say, hey, we send everybody at 8 a.m. there, collect everything. Now I think some of the city parks sends garbage bin. If you open it, you can basically come and see that there's potentially a sensor actually embedded on the cover and the lid there. And that sensor is a time of flight sensor, understand that how full the garbage bin is. 70%, 80%, send an alert to our team, parks team, and then they basically get dispatched to collect the garbage out of the garbage bins, right? And that's a great use of, say, yeah, you don't need to connect a power to the garbage bin. Deploy a sensor there and engineer it properly and make sure that you have those reporting and alerts sent out to our operation team. And IoT to us is always IT plus OT, right? IT cannot do all the work. It's all operation technology in the field that basically help us leverage the benefits. And this is the latest one that I think our team done for also parts trees, understand the soil, like the soil moisture. So embedded in some of the trees, and also you can see the reason I want to show this the other picture is that putting something on the fields also need to understand how we can protect these assets, right? So properly protect these sensors under this cover and make sure that it's tamper-proof, right? So yeah, these are the three monitoring sensors as well, and you will send some signal telling us that like does it get enough water for these trees, right? And outside, like even across the street here, a few of our manhole water levels, actually there's our lower end sensor there. And you might ask, like, why do we want to monitor this water level? I'm not sure you remember, time to time, these water level coming up, it's potentially impact our C-train services. Because there is basically high voltage equipments embedded in this manhole. And the water level basically going to put some of the hazard to our equipments, right? That's caused some of the public transportation interruptions. So the challenge here from engineering perspective is that because you can see it's a deep and underground, and also there is a metal cover. So wireless signals always have the difficulty penetrate all these things, right? And that's what you can see on the right-hand side here. I think the team cleverly designed a repeater, that little white device is out there, as a repeater, collect the signals from underground and then relay it out, right? And that's how the design being worked. And these are the things that require sort of the team here to understand the technology outside, but there's a bit customization that we need to make it happen within our soil. Things are different. There's nothing out of the box can work just beautifully here, right? We all know that. It has to do lots of the engineering pieces here. And the team recently also deployed some sensor for monitoring climate, right? You can see humidity and weather stations. And I will be interested to see our dashboard, like what does it tell me today with the snows and everything, right? And also some solar radiation sensor. I hope this one actually tells us about the northern lights, but I haven't checked with Colin, so maybe this one will give us a little bit of indication about northern lights alert. So this actually gives us lots of data collection points. Right now, the previous setup is that city probably has, or with federal or provincial, we probably have some weather stations at certain spots only. But now this gives us a lot more granularity. Say, hey, how's around the downtown work, the micro weather? How's the northwest different with downtown or with southwest? It gives us a lot more indications, right? And potentially we have been talking about either working with U of C or in our community center to roll out more sensor into our community center and understand and helping our city, community members understand that how is their micro weathers impact them, right? Wind, air qualities, stuff. So that's upcoming. And you probably saw the news, the CBC, etc. talk about, yes, the traffic noise monitoring. That's also coming from this team, the IT team. That basically we're working with our bylaw officers, and they basically provide them a tool to understand how is the traffic monitor, how does the traffic heat map look like, right? The last one to mention that also there's a merge of AI into these sensors. So we're working with the U of C to say, hey, can we basically just using AI on the edge to classify the sound right at the spot? So instead we have to send all these ambient signals back to the cloud or our data center to process AI. Let's do it at a spot. That prevents, first of all, we get much quicker reactions or much quicker actions. Secondly, we don't need to worry too much about sending some sensitive data over through the, right? Just process it and then destroy it. What we need to know is that, is this really a traffic noise or something else? That's the only information we need from the edge. And that's the beauty about these edge AI, IoT we're looking at right now, right? And the same thing applies to camera as well. I think that Colin and our AI team is actively working on say how we can put AI into some of our camera, right? And that basically helping us preserve a lot more privacy. Say we don't necessarily have to capture all the images from the streets back to our cloud, right? And our team also, like here in IT, we also deploy the RPA tool for internally to process, to automate lots of our human or mundane process. So just basically a quick snapshot here that today we we have about 40, I think this number is a little bit outdated. We probably have about 50-ish of different, we call RPA bots, across different business units to helping them automate the process here, right? And what we always believe is that take care of what is important and automate, let the machine and algorithm automate the rest, right? So free up some of the time so our employees can focus on something that they're more interesting, right? I want to cover a little bit about AI machine learning. So what I'm showing you here is the AI machine, the deep learning model that we use based on our existing security camera to find out how many people actually were during the Canada Day event. This is actually, I think it's around midnight, 10:30-ish, during a Canada Day when people gather and try to see fireworks. And you see these red dots actually is the algorithms point out these are the human objects and then give us the counts, right? So the reason we want to do this is basically helping us to do a proper understanding about better planning of event planning and capacity planning, also from public safety perspective. Right now we understand that, okay, how is this space enough for us to hold this type of event? And this is the AI model results that we use for our payment detections. With good images, you can basically see that the machine learning model actually able to detect and identify different type of defects better than human eyes. You can see some of these red boxes are the prediction results. And so these are actually capture some of the easy missed targets by human eyes, right? And until we actually work in this project, we didn't know that there's actually 10 or probably 12 different type road surface defects that we need to identify, right? So it's actually quite engineering practice. So it also proved that using AI machine learning, given its good quality of images, it actually predict and identify these different defects very well, right? Pothole actually turned out to be the easiest one. And there's other type of defects that are relatively difficult. So the prediction accuracies depends on the samples of the defects we have. Right now, pothole is so far is the easiest one to identify. We also use AI machine learning to helping our fleets asset team. So city has 3,000-ish vehicles. So we use AI machine learning to help predict, in this case, specifically say, in 2 weeks, which waste recycling truck's going to break down. And if it's break down, what's the probability of that truck's, specific truck, say number 1, 2, 3, 4, 5, is going to break down. And if it break down, what's the root cause? Is it because of the arm, mechanical failure, or what else, right? That's a really interesting study. And make it more interesting is that this result is not like 90% accuracy or 100% accuracy. This is actually only 60-ish% accuracy. And you might say, yeah, that's not good. But it turns out what we also found out is that above 63%, if I remember correctly, business-wise, we break even already. When I say break even, that means if you trust this model, just recall that the vehicles come back to do a preventive maintenance, rather than wait until it breaks. City actually save more money than just let it wait and let it break down and create more problems. So that's a very interesting finding from engineering IT perspective. We never thought about that. We said, oh, I need to get 99.99%, right? That's not the case. That's a really interesting case that in kind of helping us that, okay, yeah, you would bring technology. Let's work with our business unit and understand that what exactly is the benefit. Do we really need to achieve that higher accuracy? You might not be. And you might not be able to, right? So that's a really interesting use case, and thanks to our fleet team that actually give us the, work together and get some of these insights out. And very similar, this is for our facility management. They're the team that basically helped build this beautiful center here. So they manage about more than 100 city, I think 150-ish city buildings, right? I don't have the right number, but. So we use AI machine learning model to help them classify and say what work models, what work orders are actually predictive maintenance versus more these repair, or they call corrective maintenance. And then from each corrective maintenance, identify what kind of root cause is it? Is it because the door is broken, is the lighting is not working, etc., right? So these are all machine learning models working on behind for them now. And we also, I want to show these cases because this is how we use multiple layer of classification, helping our supply management team to understand that for each single city procurement, which buckets it should go into. So different for example, if I purchase iPhone, it basically goes to IT, the first layer, second layer could be like wireless devices, third layer is actually iPhones, right? And to that granularity is helping us understand that, okay, maybe based on that bucket, how can I budget my next year's fundings, and how do I basically calculate that based on the inflation on different categories of the devices or what we're going to purchase, right? And so this is actually right now using machine learning model now to doing this. We also use basically our OpenAI models, right, in Azure, to when citizens submit an access code, we use OpenAI on the back end to validate the information, right? Instead of humans, say validate, okay, John, Jonathan's 123 streets. So these are very simple use case, but it's very powerful. Instead of human has to validate all these inputs, the AI actually tools validate right away on the back end. And we talk about generative AI, we have to talk about chatbots, right? So we do have a few chatbots working, but right now we all contain internally. Because we want to do a thorough testing, make sure that these AI chatbots perform what exactly we need. Here's a few examples that how these AI chatbots work, right? A quick example could be Power BI chatbot for technical support, provide technical questions for Power BI licensing, technical issues, right? And also internal testing with our planning and development team for building code by law, some of these Q&A for internal training, internal testing as well. And we are building a pilot chatbot with our CSSC team to see how we can, this could be potentially going external on Kawi.ca, helping us understand, helping answer questions about low-income questions. Say, hey, if I'm a low-income, that categories, what kind of city services I can access, right? So these are AI chatbot that city's been developing. We also use, city has tons of assets, right? So instead of basically say, yeah, human take a pictures and take it down, understand, put it into spreadsheets, say, yeah, this is, for example, this is a water pump, what's the manufacturer, and type everything. So right now, the model that, the solution we use is that take a picture, and then AI capture everything, and then just dump all the details in the database for us and for our asset management team, right? So this is make the consistency going on and automate lots of these processes. Although this sounds pretty easy, but this is really extremely difficult because you can imagine quality of images, different type of assets. Is it different type of the catalogs that are available by different manufacturers? How could you make sure they have a consistent metadata, right? So actually there are lots of things happening. Remember that iceberg pieces? That's exactly happening on the back end. I also want to mention a little bit about robots, because to us, we understand that AI should not be just large language models. Eventually, it's already getting into robots, right? And so, for example, for today, if we have robots, we can clear our path with, like for snow plowing, for snow clearing. And basically, that's how the city service is going to move forward into. So with that, basically, we're working with UFC to build our Make in Calgary robots. Instead of purchasing a robot, actually, this from inside the models and even the exterior design. And what you're seeing here is the core of that we call YYC robot. And this robot basically going to be doing, hopefully can put it in the City Hall once it tests successfully. We'll come here first and then go to City Hall and basically able to do a little bit more customer services and interaction with our citizens to provide citizen services. So with that, I also want to basically summarize a little bit about what we learned. I always call AI here is always innovating. That's our definition of AI as well. And here's some of the things we learned is that we need to innovate with the strategy, right? So we do have an AI strategy. We actually published an AI strategy for enterprise internally first. And now, actually, sorry, we haven't published it. We actually get approval from ELT and all the leadership team. our AI strategy actually helping us set up our enterprise AI governance model, define our technology platform, risk management, and also have dependency on our enterprise data strategy as well. And we also cover about how do we communicate AI in corporate-wise, right? Make sure we have a consistent message. So under this strategy, actually, there's an AI working group that helping with legals, cybersecurity team, privacy team, and IT help govern lots of these in tech and provide directions. And here's our AI from City of Calgary perspective. These are our AI guiding principles, right? The thing I want to mention is basically there's accountable to people. That's always our people first guidance is that we deploy AI, we use AI. It's not because AI is cool. We need to really understand, able to measure and explain what's the benefit of using AI. That applies to other emerging technology as well, right? And we also define AI as a corporate technology. And that's why right now the AI governance, the AI steering committee is actually under the, we call CTC, the Corporate Technology Committee as well. It's a subcommittee, right? And the other thing we learn is that innovate with a purpose. That's what I say. Innovate not because it's cool or fancy. In the case I'm showing here is the one that I think a couple years the team worked with transit to help putting a radar. This is actually a 24 gigahertz radar up there to help prevent or monitor, detect the copper theft. Because I'm not sure you're aware of, actually there were lots of copper theft. They just cut those 2 meters of copper. Those are actually high voltage return. And then they sell these coppers for probably $200. But that creates lots of issues. It's gonna disrupt all the trains and basically create also safety hazard as well, right? So the purpose is that now we can have a mechanism to help detect and send an alert to our officers, transit officers, say, there's something going on out there. And you might ask, why don't you put a camera? It's because it's difficult to connect all the wires, everything to the middle of the train track. That's why some of these lower-end technologies becomes useful. You just drop a radar there, and the radar also give you a chance that basically say, yeah, you don't have to worry too much about the privacy pieces, right? This is just radar, it doesn't say anything, just reflect, right? I always press the wrong button about moving forward. Yeah. I want to say also innovate with an impact. When we talk about impact, this one talk about volume. This one I show is also with our transit teams. We have lots of buses, so every day there's hundreds of these maintenance records need to put into a system to understand and trigger the maintenance. So this is one of the, using our RPA bot, scanning all these documents, put into a system right away and consolidate together. So this one is extremely simple, but the impact is that it reduces hundreds of data entry every day. So the impact piece is on the volume, right? And what I'm showing here is the innovate with iterations. This is the third design already, right? The third design for our for transit team when they do they call the way stack. Not sure some of you understand that the way stack is that when you have a train, there's a way stack is basically there's a power cable above the trains, and basically the power cable tension need to be maintained to a certain level so that it can make sure there's the distance or the contact with this vehicle can provide the power supply to this vehicle. So any tension changes to this power could create a problem. Let's say wind, temperature, these tension cable could drop. That could create lots of public safety and operation issues, right? So how to monitor accuracy of these tension cable is a really tricky problems. You can't just find a solution and say, hey, could you somebody come here and do it, right? So this is already the third generation engineering design to put it there, using this way basically it's detecting a displacement sensor, understand it's a wheel actually, understand that how much of the displacement happened through this wire, and then convert that analog into digital, into a voltage change, and then send it through our LoRa network back. Say, hey, there's something changed. You might want to take a look at that, right? So it's pretty interesting and cool design that we put out there. And this is the back end, kind of understand that, okay, At what time, what's the temperature, what's the waste stack changes. Also, I want to say innovate with the vision too. And when I say vision, this is exactly from the pavement project. When you say the AI for pothole detection, which basically trigger another innovation is that, hey, how about we put a city camera on some of the city vehicles? Because city vehicles travel all the time to certain routes, fixed routes almost every day, every week. Should we create our own Google map or Google view? And that's exactly what we're doing now with the mobility team. These camera, 360-degree camera, was put on city vehicles. And you drive around and capture all the images. And actually contribute to Google Street as well. So right now, you go to our Google Streets. Actually, City of Calgary has lots of our street data there and updates very frequently. And the beauty about this is now imagine that we have all these data. It's not just detecting pothole. We can detect, or maybe detect that maybe traffic light is gone, a stop sign is gone, or a tree was cut, right? So lots of these becomes that, okay, these are great data that now we have to able to give us lots of insights. And the last one I want to show here is that we all talk about technology here, but what I learned is that sometimes you don't need fancy technology to innovate. This is an example that for our parks tree watering is using very old, we say GPS technology. And as simple as we put a water flow sensor there, and GPS, we're actually able to track these water trucks, which trees or areas that they water and how much water they put into each trees. It's very simple, but it's just basically say, you need to think it out of the box and implement it, right? So this solution has been in place for years and helped the business unit to understand and track what areas, like has the trees been watered, how much trees, and also actually automatically shut down the water once they see, I believe this case is like each tree 60 liters is shut down automatically, right? Last, I want to mention the people first principle was have is that, for example, we open our LoRaWAN network to the local communities, startup companies, and researchers. This is the LoRaWAN gateway that we're putting on top of the U of C building, the Earth Science building. So the entire U of C campus right now, they can use our city LoRaWAN to pilot and try out their IoT devices. And last but not least, I think a few days ago, we had our first City of Calgary AI hackathon here. And the theme is called Blaze the Trail. As thanks to our communication team, it's really great names to innovate the culture. So there are 3 themes, and at the end, we have about 76 ideas submitted about through 2 months. Lots of creative ideas. And our plans also, we're going to follow up with these ideas and how we can see how we can help them and bring them into realities. And I want to highlight last week here, these 5 teams compete at at the same spot here. And these are the 5 ideas I want to talk a little bit about that. The first one is the one that actually win the hackathon, is using AI to enhance 311 call. From 311 call, the voice call, understand right away that what the customer citizen want, and then provide answer right away before they reach out to even a human agent has to pick up and find the information. The second one is a mobile app that basically is able to take a picture of the waste, residential waste, and then telling you that which garbage bin you need to get in, right? So when I demonstrate here last week, it was actually pretty useful. I was like, I should get one of those for myself. Lots of times I'm confused, it's like, which one goes to which, right? And I just make a fun that this is, I should call that project is garbage in, garbage out, right? No, it's garbage in, treasure out. That's actually a really good app. The third one's the AI chatbot for recreation program. That's for live and play. So remember that when we had the book summer camps, book some of the swimming class, now what they're looking at is an AI chatbot able to provide citizen services, right? And there's also another creative ideas about using AI to help citizens find the missing or lost pets. So instead of identify human face, identify your pet's face, dog's face, cat's face, and then do a match. So that's a very interesting idea as well. And the last one is also the tree watering route or geospatial optimization, right? So I say, not these 5, I actually say there is other tons of other great ideas that we should help and implement. So at that, I think that's the end of my presentation. I would say, I want to say, let's connect and discuss, and then use AI. AI basically say, let's synchronize our neural networks and exchange our thoughts, right, in AI language. So thank you very much. I hope that, yeah, thanks. 5 minutes. Any questions?
Some of these ideas, I've seen other cities, like I think the city of New York does the road mapping to check all the potholes and stuff. So
Yeah.
how often are you connecting with other municipalities on stuff like this? Is there like a symposium, or how do you kind of compare ideas together?
Yeah, I think that's a really good question. I think I would say we connect very closely with Canadian municipality a lot more than the US ones. And because of the, I would say likely because of our advance in lots of our use cases and adoptions, we got contact by many municipalities and federal and provincial governments. So we have lots of regular talkings with these our partners. So yeah, it's really great that we always compare. And what we're trying to do is, especially on the AI side, to identify some of the common problems. Because lots of these use cases here are, it's not just Calgary, right? Everywhere is almost the same problems. So what we've been talking to them is say, compare notes and saying, hey, how does your model work? How does your solution work? And should we just basically make it open source to the point, right? Across these municipalities. And that's something that we have been talking to City of Vancouver, City of Surrey, and to understand that, for example, some of the problems on the water basins, where I say, how does your model work? What kind of data you collect to make it work better, right? So yeah, we have lots of those discussions going on. Yeah.
How do you ensure network security with onboarding all these IoT devices into your environment? Like if they're, what's the supply chain look like for that? Do you vet it before connecting?
That's a really good question about the security of it. Yeah, I'm glad that, Colin, do you want to take that one?
Which means that if there's deficiencies in what you've analyzed from a cybersecurity perspective, then you get the businesses that are building that ecosystem. So as an example, LoRaWAN isn't one company. It's an open ecosystem. So there's a software vendor that does the management of these devices, right? And that includes gateways and sensors. So there is a specification. Does this device conform to that specification? So as an example, the RF is AAES encryption, right? So that's fairly good standard for the radio path. But then you got to look at, well, how does that gateway now communicate with that software? And so there's existing standards, and we just have to have the discipline when we want to move to production to build those factors into securing that service down. But our confidence is very high, and it's always a continuous improvement process, which is part of our work with our cybersecurity partners.
Yeah, and if I could add, basically that's where the team here spent lots of efforts. So went through sort of the vet process, you say that typically you say, yeah, what kind of sensors could we use for, let's say, for a waste stack? There's probably 10, 20 of those. And that's where our vetting process come in here, say, through sort of a certification, understand, is it feasible to use? Secondly, how secure is it? Does it fit into our network? Could it manage by our LoRa network server, et cetera, right? So yes, definitely those practices been going on, yeah.
When we did a couple of experiments like the smart garbage, our first version of that POC, people stole the sensors right off. They ripped them right off the garbage. So yeah, like it comes in all assets. So as we early adopt, we learn and we deploy. And so like with the TIC Lab, we get to do more early adoption before we even consider implementing, operationally at the city. So.
Thank you. I hope that answered your question.
And how do you choose the projects you're going to explore? How do you choose the technologies and the applications to experiment?
Yeah, that's a really good question, and that's part of basically when it's the emergent technologies and how the intake process. We do have a matrix to understand, but it's based on different technology as well, although there's common factor. So for example, like we're looking at, say, what kind of AI project we're going to take. The intake process is looking at, say, feasibility understanding, do you have data? Basically, we have a list of, say, simple questions to our user, understand, okay, what kind of benefit, why do you want to do this? And have you tried any other things? Because lots of times right now, people say, use AI, AI is magic bullets, right? And it turns out, oh, yeah, it's probably a Power BI things. So we say, why do you use it? Have you considered other options? And secondly, what data do you have? Are they accessible? And who owns it? Can we access it? And is there any privacy concerns, security concern about your data? And then fourth, basically, we understand that has any other cities done this? Back to your question. And we're going to check, right? Say, if they have done this, why do we reinvent the wheel, right? So there's a matrix, and then after that, if this becomes, let's say, feasible, then another set of basically evaluation come in and say, how much efforts are we going to do with this one? This is like 3 months or 3 years of efforts, right? And how many integration? Because AI cannot just stay alone. So basically, there's a lot of integrations which make it more difficult. So there's complexity as well. So yes, we do have sort of a matrix trying measures. The maturity of these intakes matrix are a little bit different. For IoT, also similar, but for AIs, that's what I'm talking about, right? I hope that answered your question, Jason.
Okay, so we'll just take a quick 15-minute networking break so you can grab a coffee, use the washroom, there's muffins, cookies, whatever you need to do.
We're going to get started. Thank you all to everybody who's here in person for day 2, and to those of you who are joining us online. I think we might have quite a large online audience this morning. It's my absolute pleasure to introduce you to a few folks that have traveled quite a ways to be with us today to talk to you about ATSC 3.0 and some of the really cool stuff that this tech can do for our communities and for our municipalities. So first up, I would like to welcome Orest Shishko. He's the director of Humber Polytechnic's Broadband Convergence Lab. See, too many words. Out of Etobicoke, so right out of Toronto in Ontario. Orest, come on up.
Good morning, everyone. Thank you very much for this opportunity. Before I actually start, I want to send out a big shout out to our ATSC family, I call them here, visiting us from across the US and from Toronto. We've had Chris Lamb from Device Solutions here from North Carolina, Red Grasso from North Carolina First Tech program. We have Eric Langner from Information Equity Initiative from Florida. We have Mark Coral from Triveni Digital from Princeton, New Jersey out in the back. And we have our motley crew from Humber's lab team, including Manny Kanan, our lab project manager, as well as Willie Perez, our lab engineering manager, and Tyler Charbois, our director of COI and partnerships at Humber College. So thank you very much for your support. And as you kind of move through this presentation and their presentations, I'm really offering a prelude to what these gentlemen and these folks will be discussing today. So I'm going to provide kind of a high-level introduction of this thing that we've been talking about for the last day and a half called ATSC3. What is it? Kind of how does it work? We're not going to do a deep dive, but we'll offer you enough of an introduction to entice you to go talk to these folks and get a little bit more context from them. So what I'm talking about is kind of redefining the face of television and sort of the leaps that the technology is taking in terms of how it's moving forward in this age that we live in now. So I'm using here an example of a television transmission signal. How many of you actually watch television or receive television over the air? Okay, a few hands, a few more hands than I thought, which is great. So a lot of people may have forgotten or not realized that you can still get television over the air that comes into your home. It's kind of thinking about your television and your grandparents or parents' view of the technology with the bunny ears or the rabbit ears or some sort of, television receiver that can receive information from an antenna. The television transmission system and the conversion from analog to digital back in around 2009, 2010 was developed by an international nonprofit organization called Advanced Television Systems Committee. That committee creates and fosters recommendations and standards to advance digital terrestrial television and its ability to interoperate with other media. So they developed a standard called ATSC1. That standard allows for multiple services to run in a television channel. So let's look at the Big Blue Pipe as a TV channel. We could use, I'll pick Rogers Calgary, since we have Rogers in the audience. So Rogers City TV in Calgary running can, you know, a 6 megahertz channel pipe like this has the capability to carry multiple services in it. So I'm using the case of PBS North Carolina because we do some work with them, and you'll hear about that in the next presentation, where you can run multiple services. You'll see an orange circle there that's notified as, or indicated as data. Data has always been a part of ATSC1, but it's never really been formally utilized or commercially utilized in a large scale kind of way. ATSC1 is also at end of life. It's sort of, you know, you have in the mobile world, you have 3G, 4G, 5G, you have different adaptations and iterations of the standard that move forward. So it's sort of time for the television standard to be re-updated or be reinvigorated, if you will. So that leads us to ATSC3. I won't go into the sidebar of why they skipped ATSC2, but let's say ATSC3 allowed them to create an IP Internet Protocol-based system. And when I think of that, I often think of the phones that we all carry. So 15 years ago, you could simply talk or text on your phone, and that's all you could really do. And it kind of lived in its own world. And the broadcast system lived in its own world with its own television transmission technology. So there were kind of two silos there. But we remember that there was that 3G moment for the phone where the internet appeared on the phone. That's the convergence of two data delivery systems coming together. Now we have the ability to actually take the broadcast silo down and bring broadcast into the connected world and into the digital economy with more services to be offered to consumers and businesses. So that data pipe gets much larger in terms of IP data delivery, and it can deliver a lot of different services here, including emergency communications, educational services and such. Again, which you'll all hear about today, I won't go into detail. Yet it can still carry all your original television services, and you'll notice some of the SD standard definition services got bumped up to HD. That's because there's a much larger capacity and higher efficiency with ATSC3. The physical transmission layer specification was actually developed by a group of research scientists at Communications Research Center in Ottawa, at the CRC Ottawa. That's a federal government ICED Spectrum Lab. So this is the physical transmission backbone of this is a Canadian innovation, and we're really proud to be building on that innovation here in Canada. So I'm going to go just one layer deeper without getting too technical. Within that 6 megahertz TV pipe, we can actually now run a series of physical layer pipes or PLPs. And in those PLPs, we can actually run, for example, in PLP2, a lot of the original 4K or 2K high definition services of the regular primary television channels. We can also run in PLP1 those same services, but for mobile applications, for mobile devices. So the data is a little bit more robust. You're not getting quite as much data. You don't necessarily need 2K or 4K on your phone. 720p would work fine. So you can actually run that on a separate modulation sort of scheme or parameter that runs separate from the original 4K service. You can also now run on PLP0 very robust data services, much lower data rate, maybe in the order of magnitude of kilobytes or megabytes or a low order of megabytes, but you can actually inject more power into those bits and you can send those data bits farther, and they're much more durable and much more versatile for different things like public safety and education. So this is just kind of a high-level overview. So ATSC can serve, or 3.0 can serve as a large data delivery pipe. Because it's IP-based, it can interoperate with other IP data delivery networks, Wi-Fi, Bluetooth, and 5G. Actually, Chris and Red will talk probably a little bit about the interoperability that they have with their technology with Bluetooth, for example. So here's a big difference as well with this new standard. So the terrestrial broadcast system is infinitely scalable. What do I mean by that? The mobile network, the more devices we add on the mobile network, the less efficient the network is over time. So we're sort of straining the network at a certain point. The broadcast system, the more devices we add to the broadcast system, the more efficient it actually becomes. So you can almost say that it's infinitely scalable in that way to a large extent. It's also a difference in how we send data. To send data over the mobile system, we may be sending that data X amount of different times to every individual device. But with broadcast, we can send that data once and it can hit all the devices in the same way. Now, the big difference, is we're all aware, is that this is a unicast two-way system. So there's a great value proposition there. The broadcast system is a one-way IoT downlink or one-way link. So that allows us to look at the value propositions of how we can complement 5G service delivery, and other IP data delivery systems to allow the ability to use both highways in ways that are relevant. So we can look at one example of the use cases on the right in the form of connected cars. So let's say in the city of Calgary, there's over 1 million cars. X amount of those cars are connected. Communication with them one-to-one is going to be critical using mobile systems, but there may be a certain amount of information that's common to get to all those cars at one time. Infotainment, maybe map updates, maybe firmware updates or software updates that can all be delivered potentially over the broadcast pipe in one of those PLPs that I spoke about earlier. So what we're all about is setting up a heterogeneous system or a network of networks that can support pace planning, especially in the delivery of critical services. So at times of critical need, if the mobile load increases in the city of Calgary or any other market area, we can use the broadcast system to support that as another system coming together to work together in a heterogeneous manner. So that leads us to the smart city solutions that we've been working on with Calgary. So I had the pleasure of meeting Aaron and Dave a number of years ago. We introduced this technology, I believe, to the SEMA team through Susan Hendry and Kobe Dewar, the deputy chief here in Calgary. And that led to meeting Aaron and Dave. We talked a little bit about the technology and how it could be used experimentally here in the city of Calgary. I should back up and say that the technology in terms of ATSC3 is only allowed for experimental usage in Canada. The US and other territories worldwide have adopted the standard or are exploring the standard. So countries like the US have adopted, India is exploring, Jamaica has adopted, the Caribbean is adopting, Brazil has just adopted the physical transmission layer. So ATSC3 now has the capacity to become a hemispherical standard in the Western Hemisphere. And I believe they're calling it from Alaska to Patagonia. So there is over time that capacity for this to become a hemispherical standard. When I met Aaron and Dave, and they came out to our lab in Toronto, which you'll hear about in a moment in this presentation, I recall Aaron and Dave saying, we really want to build this right in Calgary so we could test it in our new Wave Center. And I said, you know, that's a pretty big lift, but we're happy to co-host you and provide services for you in Toronto to support your experimental testing here in Calgary so that we can ensure your success here in those early stages without burdening you with a lot of the technological requirements that are necessitated in standing up a lab. So in the Calgary solution, what we talked about is deploying various experimental applications, including emergency first responder networks, which you'll hear about this morning, digital signage for mass transit, bus shelters, variable rate speed signs, which we have a demonstration for you in the back, and in general, IoT software downloads. It's my understanding that it costs several thousands of dollars to roll trucks to individual traffic controllers, so there's an option to actually create a download system to update traffic controllers and to do an RSVP confirmation on LoRaWAN. So again, this interoperability of different networks coming together as a possible alternative to different ways of creating updates for those systems. And also from the digital equity perspective, the remote education models, which you'll also hear about today and tomorrow through Eric Langner from Information Equity Initiative. And also, last but not least, we're involved in developing a complementary PNT or position navigation timing solution called Broadcast Positioning System, which you'll also hear about this morning. That's not to replace GPS, but it's to support loss or denial of GPS services, and it's a way of integrating that service to create a more robust system if loss of GPS happens for a period that exceeds the holdover of different GPS systems. So again, the experts are here in the room to talk about that with you as well. So it's important to note that all these data casting services that we're discussing can all be carried with an existing single TV channel concurrent with the existing primary broadcast service or services. So that's a great value and brings much more value to that spectrum that's largely underutilized now because it's looking at it strictly as a television delivery mechanism. City of Calgary, like Toronto, has acquired an ATSC3 experimental broadcast license, which allows them to execute this entire engagement with us. So a little bit about the engagement. So in this slide, I've broken up our work with the City of Calgary into two key phases. So remember how I mentioned that the City of Calgary was interested in the Wave Center to set up some sort of their own technology cluster for ATSC3. And we said, you know, initially we're happy to do that with you, but it might be easier to get you going if we actually support services with you from our lab in Toronto. So what's happening in this diagram is the City of Calgary will be sending via the green arrows raw, unprocessed data from those different applications, emergency response systems, digital signage, IoT download, remote education, and they'll pipe that data across a 1 gig EPL circuit that runs direct to our lab in Toronto. We will process, encode, encapsulate the signal, make it ATSC3 ready, and we're going to send it back down a 1 gig EPL circuit to Calgary, and it's going to go right to the Harvard Tower, right to a transmitter exciter that we're setting up for you there. And we're doing that through the generous support of Harvard, Rogers, and Chorus, who are allowing us to tie into their commercial infrastructure here in the Calgary area. And that red arrow is going to beam right up through that transmitter, right up the Harvard Broadcast Tower, which I think is on the west side of Calgary, sort of out towards Canmore Way, I think. So that's going to allow us to create experimental test signal at relatively low power, so we're at about 500 watts TPO, or total power output. But it's going to allow us to do this first phase of demonstrating how some of these use case applications can work within the city. The second phase will allow us to proliferate into more towers to develop an SFN system using the broadcast towers. So currently in the ATSC1 standard, SFN is not really permitted. So what do I mean by SFN? When we drive from our homes to our businesses or to wherever we're driving, the 4G, 5G mobile system allows for data handoffs from tower to tower as we move. So the mobile system is a very intelligent system where they can move IP up those individual towers and have your data move with you as you move. The broadcast system, and I'll use the Harvard Tower or the CN Tower in Toronto, for all their glory, they're just big, dumb towers, if you could call it that. They spit out data to an infinite number of receivers, but there's no way of actually having those towers communicate to each other. Some of the key work we're doing in our lab allows us to explore pushing IP up individual towers and having those towers talk to each other. We're trying to look at making the broadcast system, or the next generation of it, much more scalable and configurable and operate more like a cellular system. So that's some of the basic work that we're doing in our lab. So that kind of leads to phase 2 of us setting up a proper SFN with multiple towers in the city to sponge out the signal a bit more effectively across the municipality, and to start to extend our reach out for some of those digital equity services. So a little bit about our lab in Toronto. So we're in this very fancy pointy building called the Barrett Center for Technology Innovation. It's a net zero energy building. I believe it's called LEED Platinum status, where it generates all its own power. So that building is hosting a number of multinational industrial stakeholders that are involved in Industry 4.0 and the digital transformation of their own respective industries. That includes robotics companies like KUKA, sensor companies like Six Sensor, Cisco Canada, Magna International. And it's really strategic for our lab to be located here, because if we can support the transformation of the broadcast system to an all IP-based system, it allows us to help supporting digital transformation of other industries. So you can start to see that there's a multi-sectoral approach to how the broadcast system can actually work. So we offer North America's only front-facing industry research center, where we explore multi-sectoral applications of the ATSC3 standard and convergence with other standards. Our infrastructure includes a full-blown ATSC3 over-the-air broadcast system and a broadcast test bed. I didn't share the diagram in the deck today, but we have 4 transmitters operating in the Toronto space. We have 3 on Humber property in northwest Toronto and leading down into Lakeshore campus near Lake Ontario. And our 4th site is actually operating on the CN Tower, again through the generous participation of Rogers and Chorus, where we tie into their commercial infrastructure and into their commercial pipe. So we broadcast Humber experimental test signal through the CN Tower through their support. That allows us to test potentially, once we come up to greater power levels, about 25% of Canada's marketplace. So there's a huge, tremendous advantage for Canadian businesses to explore this with us, as well as municipalities. We also have 3 5G core networks in the lab. So we're very serious about this convergence and looking at how we can bring these worlds together. We also have an RF anechoic test chamber and microwave test equipment to support testing and development of new links, sensors, and antennas, et cetera. So that's really important to serve all our different research activities. I've noted 2 layers of those activities here. So we do a lot of implementation, testing, and deployment work, like we're doing with the City of Calgary. We're doing that for industry, where we're taking existing technologies and developing new technologies, but we're also doing another layer of scientific research with a global research consortium, as well as ATSC, to actually advance capabilities for the terrestrial system. That particular research work is 4 or 5 steps ahead of where industry is right now, to help us evolve that research roadmap to support where industry is going to be a few years from now. Here's a couple of pictures of our lab. So we have an industry showcase, our data center, if you will, in the top left-hand corner. We are a front-facing industry lab, but we keep students and maintain students at the center of our experience. It's really crucial that we bring students into our project. So when we do an engagement with a partner, be it a municipality or an industry partner, we bring that partner together, their technical teams, with our faculty groups, and we bring students into that to be part of the innovation process. And it's really, really important that we bring students into this next generation world, because they're the people that are going to be operating these systems for generations to come. Another picture of our back-end makerspace with Willie, our lab engineering manager, and Himanshu Sharma, one of our lab techs, doing some interoperability testing on the TV side. The CN Tower is part of our test bed. One of our transmitter rooms on the far left side there that feeds one of our transmitter systems, the inside of our RF anechoic chamber. And again, a couple of shots of different students working on different industry projects. So to sum up, we foster partnerships between Humber Polytechnic and different public and private sector models and businesses to be able to lead to business innovation at local, regional, and national levels. We directly transfer that knowledge and technology to our partners. We're not in the business of retaining intellectual property. When a partner comes to work with us, they are free to take, they basically own that IP, and they walk away with that IP, and they're free to commercially exploit those IP findings as they see fit. So we provide a supportive, low-risk environment where partners can transform their ideas into these marketable solutions. And also, as the point is noting above, development of these new products and services with enhanced functionality. We offer access to highly qualified faculty with advanced technical digital entrepreneurship and soft essential skills. And again, keeping students at the center experience is really key for us. And at the end of the day, we become a knowledge hub for these different applications and how it can converge with other IP standards. And that allows us to disseminate that information. So for example, when we work with an industry partner, we are able to set up industry workshops where we can have those partners share their innovations and what they've developed with the general public, so we can serve as that effective hub. And with that, I come to the end of my presentation. And again, thanks to all our ATSC family that are here, and we really look forward to hearing from them. The last person I was remiss not to mention was Vlad Anishchenko from Avitech Corporation, who's also a key part of our family. Thank you very much.
Thank you, Orest. So as Orest mentioned, we've got kind of a lot going on at the City of Calgary, and a lot of different ways we're looking to leverage this technology to help make things better for Calgarians and some of our neighboring remote and rural communities. One of the things we're exploring is communications with our emergency responder network. So I'm going to invite Red Grasso up along with Chris Lamb. So Red is the director of the First Responder Emergency Technologies Program, or First Tech, out of North Carolina. And Chris is the CEO of Device Solutions. So they're going to give you an overview of what they've done with the first responders in North Carolina and how they were piloting this technology out there.
Good morning. Thank you, everybody. Appreciate the opportunity to be here and keep working with the team, Orest's team, and everybody else. We've had a lot of fun trying to combine things and implement some new technology. I'm Chris Lamb. I'm the CEO and co-founder of Device Solutions. We're an engineering services company, so I say we do the stuff inside the box. We do the embedded software and the hardware to make the things and the Internet of Things. We've been doing this since 2003 when we escaped from Sony Ericsson, where we did 2G data. Anybody remember that? 9600 bits? No? All right. So we did 2G and 3G, and some of us were on the leading edge of the 4G stuff. But we do things that look a lot like cell phones still. They have batteries and radios, and they tend to go out in the field, either industrial, consumer, medical devices as well.
And I'm Red Grasso. As she mentioned, I work for the state of North Carolina. I actually started my career 10 years as a career firefighter and then ended up in the technology space. And I know there are 10 kinds of people in this world, those that understand binary and those that don't. I'm smart enough to know it's a joke, but I like to surround myself with engineers who can actually get more technical. You have to forgive me, I felt really combobulated this morning until I saw Orest's slides and realized that I've now misspelled fiber and center for my entire life. So I'm a little discombobulated, questioning my entire education. All right, so I do want to call out our partners. I won't read them out, but this project has been a great thing to be involved with. We've had a lot of different people involved with trying to actually bring this to reality. So I kind of want Start off, Urs did mention our family. We do pick on PBS North Carolina a lot because they have been a great supporter in providing not only some of the technical expertise, but also the towers that we've been using and some of the transmission facility for it. You'll also see, what's that?
And access to the whole broadcast community.
And access to the whole broadcast. Yeah, they have really made a lot of introductions around the entire community. And I believe that's how we also met Orst, is from our partners at PBS North Carolina. Orst mentioned it as a family. You'll see that we stole the same slides. One of the things that I did want to mention, just to reiterate on what Orst was talking about, this whole pipe of television, when we talk about the data casting and that data ability, that is completely separate from the content being shown on a television set. So there's a couple of different analogies, either like a VPN or like your cell phone. Your cell phone might be connected to the same tower as your neighbor's cell phone, but you've got your content, they've got their content. You're not seeing each other's streams at all. And so this data casting ability, whether we're delivering it for emergency communications, whether it's education, it doesn't have anything to do with the content that is being shown on the television channel. This pipe does end up separated, so you're not really worried about trying to have something separate that somebody else is going to see. This can be very targeted, and very importantly, it's going to go to those who need it and not to those who don't. We talked about data casting a little bit. Again, we've got a very specific use case that we're going to show you about, but this slide deck was kind of meant to give you, in case Urs didn't give us the great intro, we talk about data casting and its ability to deliver that IP data over that television transmission stream. And it can really include anything that is IP based. I don't really know why government has to include blank things, but I wanted to make sure I didn't get in trouble. So we do have a blank slide here. I did want to ask, as we move away from talking about the television and more into our use case, how many people here have had to dial 911 to report an emergency? It's about half, and I'm not sure how many people raise their hands online. I do want to...
How many have had to dial it hundreds of times to test the cell phone?
I did want to recognize our online folks. I am glad that to be here in person with everybody online. I'm glad that you're not sharing your cameras. I know it is No Pants Tuesday, and we're glad that you're remote. But what I wanted to walk through is what happens after you dial 911. We all know that about 85% of statistics are made up. We know that they're more believable if there's a decimal point, but about 70% of our responders are still in rural areas. And in that rural area, they are using a paging technology to get the information from the 911 center out into the field. So I've got a slide here, and it's got a little bit of video and audio. I'm gonna watch our controls here. I'm hoping it's not too loud, but we're gonna see how this goes. And this is from a real 911 call, actually in the St. Louis area in the United States. And it's of a kitchen fire, but this is after you call up and say, my kitchen is on fire. So the fire's still growing. Oh, that's my volume too. So the fire's still growing, and yet we don't have any idea where this fire is located yet.
4034, 4024, 4125.
Finally, we start getting a voice.
3735, 3720, 4027, 4002, 4102. Respond to first alarm, Florissant. Kitchen, 450 Naomi Avenue, Pressure Bob and
We finally know the location.
4034, 4024, 4125, 4114, 3735, 3720, 4027, 4002, 4102. Respond to first alarm in Florissant. Kitchen, at 450 Naomi Avenue, Pressure Bob and Ray. All units respond to TAC 10, TAC 10, time is 1220.
People were watching the fire grow. Turn this up a little bit more. I don't know. We'll see. Yeah, maybe 2 and 3. All right, so I'm glad you were watching the fire grow, because as a presenter, this part of my slide is really awkward because I'm just sitting here, which is really tough for me. But I mean, that is a real alert that goes out to responders. Now, I want to call out that we didn't really highlight the technology that some of them actually have computers in the trucks and they may get it over the cellular network. But that is how the voice dispatch occurs with those tones and that type of what we call a tone and voice pager. And that is still happening today in North America, particularly more for our rural, sometimes the suburban, sometimes urban areas. We did not ask them to dispatch during our thing, but
lots of rural. Right?
Lots of
Many of the volunteers just have a pager, and this is all they get.
that's
And
right.
Maybe they can't understand it. Maybe they can't replay it. Can you tell, apartment 101 from 102 in the announcement? Maybe hard to tell.
Yeah, yeah. And the pagers have advanced. These types of pagers, they do now have a little bit more ruggedness. They have a little bit of a display, so you can tell the battery level, all of that kind of stuff on it. But really, the technology is from 70 years ago. A little bit more audio for you.
Maybe we should have done this after lunch to wake everybody up.
Yeah, right. Should have been an after lunch presentation. So that is from the show Emergency from the 1970s. If you didn't recognize it, then you might be younger than I am. But I mean, I want to call out, these are extremely reliable, but this technology has been around a long time. And part of what we looked at when we met with PBS North Carolina was how do we advance this? So now we'll get back to a little bit before we do that, one of the challenges that we have with these tone and voice systems is that they are really siloed. In the US, a lot of these are county by county, so not necessarily municipal, but a little bit regional, but definitely very difficult. We've gotten very good in North Carolina at getting our 911 calls moved to a different part of the state. We do get to host a lot of different hurricanes, as well as other disasters in our state. So let's just say, for example, if a hurricane were to hit the western part of our state in the mountains, we are able to move those 911 calls to our coast and have those 911 calls answered. The problem is that Asheville can transfer their calls to Raleigh, and they can say, 911, what's the location of your emergency? And somebody says, well, I'm in downtown Asheville, and I have this emergency. Raleigh can take that call and they can understand that message, but Raleigh has no way of dispatching Asheville engine number 1 because they don't have access to that siloed tone and voice paging system. They don't have access to really get that in there. And that was one of the problems that we were faced with. Luckily, PBS North Carolina has pretty wide coverage with all of their transmitters. So part of this idea was, what could this look like to really regionalize and bring together all of the dispatch information across our state? When we talk about data casting, we did steal a term, high tower, high power. Typically, our television stations are 1 million watts of power, usually about 300 meters tower height. So a lot taller than what our public safety is using today for some of their land mobile radio and some of their tone and voice systems. It's scalable, it can be encrypted. You can read all of that. One of the big advantages that we like is that this prototype device, this technology, because it's listening to a television broadcast station, it's always going to know where it is in coverage. So if you do walk into a building, if you walk into a subway system below ground, this new device will actually know whether it is in coverage or not because it's listening to that television broadcast. So with that, tying it all together, the prototype that Chris's company has made is this sort of device, and we have tests that show within a second, you get all the data you need from that 911 center with the full alert. It does have an onboard text-to-speech, so it's still able to read out that information. So if you are a responder driving home from your job and an emergency comes out, the speaker can still tell you where all this information is. I kind of ran through pretty quick on that, but I'm going to turn it over to Chris to get a little bit more technical on this paging device, which he brought with him today.
All right, thanks again, Red, and everybody for coming out. I think we should back up a little bit and mention why we're doing PBS in North Carolina for all these examples. So originally, CTO at PBS North Carolina had the idea of could we use ATSC3 for the emergency paging. He approached Red somehow. We ended up with a Fred and Red team. Don't know how that happened. They came up with an idea, wrote a white paper. That was submitted to the Department of Homeland Security, who wrote a solicitation, and we applied for a contract for a small business innovative research contract to develop a prototype pager. And little did we know when we applied, Red and Fred team were right in our backyard, literally like a mile and a half
Yeah.
away. So they came up with the idea, we went off and implemented it. That's why you see so many of these references to North Carolina. So as Red mentioned, there is a speaker, but we think one of the important use cases is also we support Bluetooth, so you can get the alert information on your phone. You can get things like map updates for your phone, as well as the address can be a link. So you'll see the page, look a lot like a text message, press a link, and you'll get your directions and things like that. Just
Apparently
keep
I
going.
messed it up.
All right. So as I said, this was DHS funded, so we did what's called phase 1 and phase 2, a little bit over $1 million. We're working with ORS to build maybe another batch for use in some more field trials. And we've done a lot of work with a partner called PageTrack, they're on the first slides, to get actual real data from 911 centers called PSAPs, routed through our system, broadcast over a live ATSC3 television channel in eastern North Carolina. So even today, we're continuously broadcasting actual pages and getting coverage 100 kilometers away
100 kilometers.
in building. So with our high tower, high power, 1 million watts vertical orientation, horizontal, another 500,000 watts, we're getting high tower, high power, penetration deep in buildings over a very wide range. Even at my office, which is over 70 miles, if we sit near a window, you'll get the page. So much better coverage than these county by county systems or even department by department systems that we see in a lot of areas. Advance. There we go. So there are also some other uses. There are a lot of emergency alerts. We were listening to another video earlier that, and we'll see during some of the other demos, some of these alerts. But iPaws and things like this are these emergency alerts you get on your phone or on your radio, several different systems for doing that. They can all feed into the ATSC3 transport encoder, which we get from Triveni, and they've enabled all these demos, and then out over the broadcast system. So we can provide a unified way to do first responder paging and dispatching, but also consumer and end user alerts. These alerts could tie into other systems in the city, whether it changes the way the traffic lights behave in an emergency, evacuation routes for flooding. You hit the evac mode, that goes out over the whole city, and things could change the way they operate. Street signs, as we have also an example back there, you can broadcast information to those over a very wide area. And because it's IP-based, it can be an image, it could be an audio file, it can be whatever you need it to be, and the bandwidth dedicated to each one of those PLPs or physical layer pipes, they're essentially subchannels. We can adapt those for the situation. So you can, in an emergency, scale everything back to standard def or even lower, and then focus on getting emergency data out. There are also applications that we're working with NASA and some other partners with drones and firefighting aircraft. So if you're fighting a wildfire, you need a signal to cover a large area. You can't fly the tankers and things like that if you have drones in the air. So this is a way to get to the tankers and to the drones. Here's where you need to be, here's where you don't need to be. There's going to be a whole system that NASA's developing for managing data to the drones, where are the drones, and keeping track of them as we start to have things like air taxis and delivery drones, because you don't want them running into each other. So we're working with several experiments to do these kinds of things to get data out and avoid collisions. Yep. So the other use case we've been talking about is for FEMA, again, in situations like we have in Asheville right now in western North Carolina. How do you get data to citizens about where the water is? How do you get data to them? What's the current instructions for boiling water? What other alerts and aid drop-off may they be? We currently have a weather radio system, and Red's got this map here, but as you can see, even for a small state, well, even for one state, it takes a lot of radios to cover that. So you want to add to that?
Sure. So what we're looking at here, this is, so the National Weather Service actually runs different VHF transmitter sites across the United States. There's actually over 1,000 of them. But just like any tower, these towers usually aren't too tall and they're not extremely high power. But if you have, there are some overlapping coverage, but you can see that there are some areas that aren't covered at all, and you can see that there are some areas, or a lot of areas, that are only covered by one tower. So the loss of that tower means the loss of connectivity for information to the public. So again, high tower, high power, using a data casting method could overlay this entire thing. And one of the conversations that we've had before is from the wildland firefighting side. It's very difficult to defend multiple towers, particularly either these types of towers or cellular, versus having to defend a single television transmission tower. So part of the use case here is that it provides a really redundant overlay that has a much wider geographic coverage area than some of the other systems that are used today.
What are the statistics for the recent event?
Yeah, so recently Hurricane Helene in North Carolina took out about 1,500 cellular towers. It did not bring down any of our television transmission towers, except for the loss of fuel to a backup generator to one of the commercial partners. But PBS North Carolina actually stayed on the entire time. So, yeah.
That's really the advantage of all that. So do you want to?
And then, yeah, I mean, just sort of wrap. One of the other disaster du jours, but the pandemic in 2020 really highlighted a lot of the digital equity and digital connectivity disparities throughout our regions, and being able to deliver targeted content and really controlled content. So I can't imagine the scary thought of just giving an 8-year-old access to the internet and having them do their homework. There's a lot of bad stuff on the internet. I don't know how much you've explored it at all, but I downloaded all of it to my phone and was amazed. So the ability to use data casting to really do controlled content where they're getting assignments from their teachers and that's what they're able to access, I think is another tremendous value proposition for this data casting aspect of 3.0.
And that can be live data, or it can be like buffered, right? Overnight, you can be downloading class data, watch those videos later. You know, you could have a whole repository to be viewed at your leisure. It doesn't have to be in real time.
Yeah. That, in a nutshell, is sort of everything we had to throw at you as quick as we could. So I'm hoping that it generated maybe some conversation or some questions for you. Our contact information is up there. I have business cards if you need something for your trash can, but feel free to ask questions.
And so last but not least, for speaking today, I have Mark Coral, who's going to come up and chat with you about some of the broadcast positioning system and the timing. He is the SVP of Emergent Technology Development at Triveni Digital. So they look at really disruptive change in television broadcast, leveraging some of ATSC3.
Thanks, Aaron. What I'm going to... Hi. We have a clicker here. Here we go. So this is a real, something completely different, like Monty Python. This is something that was discovered by NAB, or invented by NAB, which is the National Association of Broadcasters in the US. And really what had happened, let me just start the presentation. Really the problem, and perhaps the solution, is that the GPS, really in the United States, our economy is really driven by GPS. Most people don't realize that. I honestly didn't realize how much of our infrastructure was based and relied on GPS. So even our energy and power grid, for example, it's kind of interesting because who would have thought it, right? Why do you need positioning for your power grid? Well, it turns out the important part is time. If you have alternating current, it's a phase. And if that phase is not synced to the overall network, you start losing power. So there's these things called synchrophasers that are actually synchronized to the clock that comes out of GPS. And that keeps the energy system running, in essence. And if GPS is blocked, it becomes less efficient. Communications, obviously, our cell towers are all connected together. If you move from cell tower to cell tower, they all have to know what time it is. Otherwise, your phone gets freaked out and doesn't know what's happening. Financial transactions, that's another one. Every transaction that you do in an ATM is timestamped to a microsecond. All of the transactions that happen across the globe are timestamped to a microsecond. So, you know, currency changes pretty quickly sometimes. And so all of that, but in the US, that's all based entirely on GPS, that time. There are backup systems, there are systems that run over the network, but primarily everybody uses GPS. So what happens if it breaks? There's a lot of jamming. You'll see a lot of reports lately about GPS being jammed. The other problem that we have in the US, and I think it's actually here in Canada as well, and in many countries, there's no backup system. There's no complement to it. If it fails, there's actually quite a bit of information that says that in the US, we would lose roughly $1 billion in GNP a day. So what we were thinking about and what came up with is we can use BPS, which is a broadcast positioning system, and it's probably badly named right now because we aren't looking at it for positioning per se, we're looking at it for timing. And really, we really need to really kind of have a complement to what would happen if, for example, just big solar flares take out GPS all the time. I mean, it really just, it's a long way away, these signals coming out of a very relatively low power, and it's really hard to pick them up. So the Department of Transportation has come up with a PNT action plan, and as part of that, that's where this technology is being derived from or done for. So here, as I mentioned, some of the technical requirements, the critical infrastructure and usability needs. Mobile wireless networks, roughly a 1 microsecond requirement for time, traceable back to, and when I say traceable, every country has essentially a thing like NIST. In the US, we have NIST, which is an organization that does the clocks for the United States. They set the standard clock. That actually, all the countries then feed back into, I think it's Paris, I'm not sure, in some place in France, and they set the global clock. And all of that then has to be traceable. You have to be able to prove that you can trace back to that timestamp, which is UTC. UTC actually has a leap seconds in it. There's another standard, and I'm going to get really nerdy on you because I know more about time now than I ever wanted to know. And so equity trading systems, for example, 1 microsecond. There's actually rules in the EU that are starting to talk about sub-microsecond time synchronization. The power grid, as I mentioned, 1 microsecond. And just about all of the other critical infrastructure industries, 200 nanoseconds satisfies all requirements. And when I say 200 nanoseconds, there's a pulse every second that's sent out by NIST. And that edge of that second is the real time in the United States and in Canada and every place else. So there's this timestamp that's coming out every second, and you need to be within 200 nanoseconds, plus or minus of that, to meet these requirements. So why the BPS? Why terrestrial broadcast? Why is that an interesting solution? We, in the US, and NAB pilot, you'll see them down here, NAB is sponsored, and their members are actually the folks that use the high power stations in the United States, whether they be public broadcasting or commercial broadcasting. These numbers are exactly the VHF and UHF stations that are not low power stations. So there's a whole bunch of low power stations, a couple thousands of them in the United States. They aren't attributed here. They're not included in these numbers. But you can see there's 2,000 stations here. And so the coverage map, this was done by modeling by NAB. So with a threshold of 20 dB, and again, nerd techie stuff, you can see the coverage. Basically, we can cover the entire country. If you set the demodulation threshold. This one's a number that's really interesting, this minus 5 dB signal to noise. That means the noise is below, or the signal is below the noise floor. And we can actually pick up with those receivers, we can pick up that information. We can see that. We can somehow, and I don't know, it's all black magic to me, somehow they pull that signal out of the noise and figure it out, right? And we have a lot of forward error correction. We have a lot of capabilities built into ATSC3 that allow this to happen. That's why we have such good penetration and such good receivability. So what the broadcast positioning system is, a system and method for estimating time and position. Really, we're focused on time using the Next-Gen TV broadcast. And when I say Next-Gen, that's interchangeable with ATSC3. That's the brand that we're using in the US for ATSC3. ATSC3 is a set of standards. Next-Gen TV is sort of the marketing pitch of deploying those standards. The BPS system was completely compliant with that. We didn't have to change the standard at all. It was actually built into the standard already. We just needed to make it more precise. And it's completely independent and standalone from GPS, internet, or any other technologies. So I'll go through this. Vlad, do you want to do some? I think there's a couple slides. No, of course he doesn't. Vlad doesn't like public speaking, but I drag him up here all the time. So how does it work? So in this case, this is a frame. So the way the ATSC standard works is it's busted into frames that are analog, sort of analog waveforms. And the waveform can really be thought of as the bootstrap, which is sort of tells the receiver, oh, here's this signal and here's how to access this signal. And that bootstrap is very, very robust. And most receivers can see that. Then there's a preamble, which is slightly less robust, but still very robust. And then the payloads. And this is where you see previous presentations, they talked about PLPs and things. That's all baked into this payload part. Well, the time is actually in the preamble. So in the preamble, there's a timestamp that, as you can see up there, an L1D means basically the preamble level 1. And they basically have a nanosecond resolution we can put in there. The reason it's busted into that because there are allowances in the standard to have different resolutions of time in the broadcast. For BPS, we use basically the nanosecond. And so what happens is every frame that comes out, and frames are sent out roughly depends, it's configurable between 50 nanoseconds and 5 seconds. Most broadcasters right now in the US are using around 250 milliseconds, sorry, which is about a quarter second. And so there's quite a bit of payload stuffed into there. Those bootstrap symbols, it's only about, I think it's like 4 bytes or something like that, maybe 8. It's very small. And what this time information position is, this value here that we've called out, that time information is basically when that front symbol, we'll call it, that bootstrap symbol leaves the transmitter. So the minute that waveform leaves the transmitter, this timestamp is supposed to tell you when it left the transmitter. So when I see that signal and it hits my receiver, I say, oh, I know when it left, I know what the speed of light is, I can figure out, and if I know where I am, I can figure out, how far it is from the transmitter and therefore what time it is. And if I can see 4 of those transmitters, I don't have to know where I am because now I know I can triangulate. And that's where the positioning comes from. And this is no different than the way GPS works, honestly. So the modules we have in the system, and Avitech, Vladimir's company, built the synchronizer and the receiver. We have basically, it measures everything and corrects things as they move forward, and we can look at other devices, other transmitters that are sending out the information as well. It sends correction information to what is called a BPS-enabled exciter. We can change, so in other words, it looks at the transmission and says, oh, you're off 150 nanoseconds. Please adjust the time that you're sending. And so there's a control loop that we set up, and it manages the system and the control of that system in real time, frame to frame. And then the BPS aggregator, which my team actually is building, we connect to all of these devices and basically give sort of an up-level information dump and be able to track all of this stuff, and then also feed back into what would be a network operations center if we deploy all of this across perhaps North America, for example. We would want to have a network operating center that understands how all of these things are working and if anything's broken. So we're actually actively working on that right now. And I can show you pictures of it if you like on my laptop. So this is how the system is actually put together. This is at a transmitter site. So you see the Avatec synchronizer here, and that's connected back into the exciter doing this. So you can see there's a loop here, a control loop. And the important part here is the reference clock. So the reference clock tells the synchronizer how far it is off of time. Now we can use a variety of different signals into those reference clocks. There's manufacturers that build these things. We've got 3 manufacturers now with different capabilities, and they will track time. They can use GPS, they can do whatever, but they have very long holdover times. So some of the devices we're using have a 2-week holdover, and by holdover I mean if they lose their reference clock coming into the device, it has some physics in it that can hold the clock within a very tight tolerance for a certain amount of time, so you're not drifting off the time. The ones we're using in what you'll note later is called the follower. They can do roughly 2 weeks. The ones we have in what will be called the leaders or the reference stations can go as many as 2 months without an input signal. They're based on cesium clocks. The ones that are 2 weeks are only Macers. It's kind of fascinating technology, honestly, that I have nothing to do with. I just buy them and we install them. So this is on the receive side, the Avatec receiver. This is where we basically pull in information from the broadcast and about where so some of the information that's put in is about where the broadcast tower is. That's part of the datacast that's coming over from the tower. So we see what time it was, we see where it was coming from, and then we can replicate and generate these. 1 PPS is that 1 second time sync that I was talking about, and that comes out of the receiver device. So just by using the receiver device, we can set time wherever that receiver device is. And this is all being tested at Humber. This is one of the things that Orist's team is working on, and Avatec happens to be in Markham, which is very convenient because they can see the signals coming off the towers. And so everybody's sort of working on this. So they're working on a variety of different things here. You can read this. But really the nice thing about BPS is it's really hard to jam. As Red mentioned, like WUNK in North Carolina, it's a 1 megawatt transmitter. It's really hard to jam a 1 megawatt transmission. You need a lot of power, whereas a satellite, a lot easier. And then if we do this on multiple frequencies, on multiple transmitter, now you have to block almost the entire spectrum at a very high power. So it's much harder to block the BPS signal. So this is sort of the UI of the Avatec receiver. This is finding that this is the control information. The interesting one here is, and I made all those points about the 200 nanosecond, because this is how well we're doing. This is a graph of, this is actually in microseconds. So that's 7 nanoseconds. So this graph is showing how well the transmission is working over time. And you can see we're plus or minus 10 nanoseconds, drifting a little low. But right now, we're well within specification of the requirements for the infrastructure necessary. And this is some of the information that we're sending out in the broadcast. This is Datacast. It's called BPS Info. And that's what the software that my team is writing generates that. And then Vladimir's team pulls it apart and puts it in the broadcast and sends it forward to more of my software that my team's generating. So what we have at the end, right now, there's live trials going on. You can see the B2C lab in Humber. We have the NAB pilot laboratory in Washington, D.C. That's actually where we're testing all of this, because from there we can see WHUT, which is Howard University, they're running right now, as well as WNUV, which is Sinclair. They're just about to put it on air. They're like a day away. The WGN is actually interesting because this is being done in collaboration with NIST, and that signal is going into the NIST laboratories in Boulder, Colorado, and they're measuring, they're comparing the signals coming out of the broadcast with GPS and seeing how they're actually doing science to figure out how close these signals are, which is really exciting because they say it's working pretty well. So that's the NIST-B. So this is where we really want to go. So you imagine a whole collection of transmitters. 3 of them in this diagram have what is known as traceable time clocks. The rest of them, the follower nodes actually have holdover systems in them, but they're not necessarily traceable back to the NIST time. So what we want to do is send information, and one of the slides that we didn't have in this deck was a measurement of how transmitters can see other transmitters. With a antenna, a receiving antenna at 50 meters, you can see roughly 70 transmitters in the United States from just about every tower. So if I put up a receive antenna on my transmitter, I can probably see about 70 stations. And so finding 3 of them that actually have this is pretty easy. So each of those is sending to the followers. The followers can see a leader, but the followers can also see themselves and their neighbors. So essentially, all the systems can see all the other systems. And what we're building and working on is essentially a self-annealing mesh network that will combine all the towers and measure all the towers from tower to tower. And we're looking for funding from the government to actually do this in the US. But hopefully we'll be actually able to demonstrate some of this capability at Humber in the coming months. And that's what we were really here to talk about. You can see we have diagrams of running systems back there, or actually live UIs for the running systems back there. One's in Markham, one's in Washington. We can see all of that from here. Any questions? Eric.
So you mentioned 50 meters, the tower to tower.
Yeah.
But on your earlier slide with the 10 and 20 dBU reception, what is that at, like human height? Or
Yeah, it's 1.5 meters. But you can't see 70 towers at that height. You can see roughly 7 or 8. The other map that I didn't include in this deck because it was sort of short on time or didn't want to spend a lot of time, there's another map of where WH2T, which is about a 500 kilowatt transmitter out of Washington, I actually could see that theoretically at my house in Princeton. So that's the kind of reach these things have at that robustness level. And we're not sending a whole lot of data. You can't send a lot of data at that robustness. There just isn't enough room for it, but we can send all of our, you saw the amount of data there, it's not a whole lot, it's a couple of K bytes, and we can put that into the broadcast into that level and actually have it get to a large, pop area. And we don't need very many of them, but we really would like to have all of the ATSC3 transmitters turn this stuff on, because then we have a full country coverage. There was another question? Oh, lots of questions. Good.
Me?
Yeah, go ahead.
I was just wondering about the data rate you just mentioned. Is there any way that you could multiplex the state so that you could improve the data rate, or would
Sure.
that?
Yeah, I mean, we can boost the data rate. The problem is in ATSC in these broadcast systems, really when people talk about 57 megabits, right? That's sort of the bandwidth we can get out of a 6 megahertz channel. The reason we can do this robustness level is because we're using almost almost more bits for forward error correction than we add for the data. And so there's nothing for free. If you want to get robustness, you have to add forward error correction or QPSK or some other technologies, right? We have a number of different tools and dials that we can dial in to get that level of robustness, but all of them cost in some way or another. And ultimately, you end up with, okay, I can send a megabit perhaps at that robustness level. And I can compress the data and I can do a bunch of other things too, right? Right now, we're just sending binary data. We could compress that if we wanted to or make it cleaner. But there's a lot of techniques that we're using. So especially in the audio and video, we've just moved to another, like BBC instead of HEVC. We just used another technology for that. And you can see that back here on the screens.
So is that robustness why you can still receive a signal even if your sound to noise ratio
Yes.
is okay? Excellent. Thank you.
Yes. Yep. There's two of you right back and forth. So fight it out amongst yourselves.
I might have missed something, but the purpose of the BPS, is that to synchronize the towers, the signals off the towers, or is there multiple?
So the BPS system and the mesh network is to basically make sure that all of the transmitters are operating nominally, right? And so we can see all the transmitters, but the goal of that is to basically have a transmitter that's emitting the correct time from a known location. There will be other receivers, perhaps cheaper receivers that are that are built that will sit in power stations, that will sit on cell towers, that'll sit, you know, wherever and be able to pick up the signal, just like you have a, you know, little handheld or my watch that can do GPS. You'll have technology like that, and all it's doing in life, excuse me, is picking up that time and then reusing that time and redistributing that time throughout whatever infrastructure area you want. And so we really aren't thinking right now about positioning, though if we can maintain that, you know, 5 or 6 nanoseconds. A nanosecond is a foot, roughly. It's basically 11.9 inches. I think I did the math one time. And, you know, so 5 nanoseconds is this, right? It's not very far. And if you can get 3 or 4 of those, plus or minus, and do the math, you can get yourself within a meter pretty easily. But we're not really focused on position right now. We really are focused on time. And if we get the time, the position will come.
Robustness at home with like a 20-foot tower and a high gain antenna, I can just barely do video because the stations are like 70 miles away. But with the pager inside, I can pick up the time.
Would take place outside the broadcasting system. I mean, 3.0 is a demonstration. We saw how PBS was kind of central. They were piggybacking on that license. Is that going to happen with this as well, or would this be something external to the 6 megahertz license that broadcasters get?
No, some of us who really want ATSC3 to take off are hoping that the government says this is a really cool idea, thou shalt do ATSC3 and drive regulation. This is part of the standard. I mean, the time stamp is part of the standard. It's been part of the standard for 10 years. What we're doing with Abitech and the technology that we're deploying is making sure that timestamp is actually precise. And that's the key. But it's part of the standard. Actually, all the video and everything else runs off of that time. So the reason we put a TIA time in the system was to basically have a basic time. Like in the current HDTV system, there's just a running clock. It's not synchronized to wall clock, it's just a running clock, and all the video synchronizes to that. In this system, everything synchronizes to wall clock time. So your video, basically you can tell the receiver, okay, turn on the video at thus and such time, and it will know exactly what time it is. Dave.
Yeah, excellent presentation, Mark. I was just wondering, are you seeing any recognition from the federal government that GPS is a vulnerable technology, and are you
Why,
seeing
yes. So you've seen articles, you may have seen articles. A good reference is nab.org/BPS. There's articles, there's papers that I've written and some of the other folks in the room, Vlad, have written. There's papers out there as resources. There's also references to New York Times articles specifying how badly we are broken, let's say. And as Pat Diamond, who's on the PNT, there's a PNT advisory board into the Department of Transportation. And he characterizes it, the United States has been admiring this problem for 20 years and not solving it. So they are very, very aware and very interested in this technology. But there was actually a presidential edict to come up with a complementary system. And the Department of Transportation is actually funding multiple trials in different technologies, some of them LEO, some of them land-based, including the BPS project and some others. So they're actively working on it, how long it will take. We think this is a great system because it's actually a very low lift compared. We spend, you might want to know this, as Canadians using the GPS system, the United States spends $6 billion a year maintaining GPS and correct time. That's just to keep a satellite, putting up a GPS satellite costs roughly $60 million. We think we can do all of BPS, all of the entire country for a little less than that. it won't be billions. It'll, you know, it might not even be 100 million. We don't know yet, but you know, we can do pretty well, and I think it's a good expenditure by the government. But I'm a little biased.
Well, Forrest. I was just going to add to Mark's comments. For those of you interested in learning more about BPS, Humber actually hosted a seminar called Protecting GPS with Resilient PNT Solutions. And we invited up the U.S. Department of Transportation, members from Transport Canada, the ISED PNT chair, Jennifer Warren from Ottawa, as well as two members of the U.S. National Space-Based PNT Advisory Board, Dana Goward and Pat Meyer, and some other folks. So we had a panel presentation. All that information on BPS is available on the Humber Polytechnic Lab website, b2convergence.ca, so you can learn more about the context. And there's that really great panel discussion following together to share their thoughts. Thanks, Brian.
All right, anything else? I'm glad there was a lot of questions. That was good. Thank you.
Okay, hi. Going to get started here, I guess. My name is Mike, and there we go. I'm a project management consultant with the city's business and local economy team, which is part of collaboration, analytics, and innovation. So today, obviously, we'll be talking to you about Calgary's 5G Discovery Zone. The concept of the Discovery Zone emerged as from the city's wireless infrastructure deployment program. And we started pursuing the idea of collaborating with wireless service providers back in 2019. So this program has been years in the making and was developed in collaboration with Rogers Communications, Platform Calgary, and Calgary Economic Development. The collaboration between private and public sectors is a great demonstration of the city's dedication to collaborative leadership, innovation, and supporting the local business community. Now, the Discovery Zone is made possible by Rogers Communications, and it's my pleasure to introduce you to Chris McCarroll and Cameron Henning.
Thanks, sir. As Mike mentioned, my name is Chris McCarroll. I am the Senior Manager of Enterprise Sales for Rogers Business. One of our key accounts is the City of Calgary, and so we're very lucky and fortunate to get to take part in not only the relationship that we have on the connectivity side, whether that's wireline or wireless connectivity, but as Mike kind of alluded to, the collaboration that we enjoy with the City of Calgary, Platform Calgary, and the launch of the 5G Discovery Zone. So that's what I'm here to talk to you guys about today. All right, great. So here we go. We're unlocking innovation with Calgary's 5G Discovery Zone. So this was our introduction, which Mike gracefully already provided. So the 5G Discovery Zone, we're going to use the term collaboration a lot, truly is a collaboration, and the intent, of course, is to enable entrepreneurs, small and medium-sized companies, through their access to this technology. So a lot of this couldn't be possible without the partners that you see on the screen there. Sorry, I got to get my notes here. So I'm going to give you a little bit of boilerplate, and then I'm going to talk about what each one of these partners have really brought to the table in terms of the Discovery Zone. So the goal of the 5G Digital Playground, or the Discovery Zone, is to provide a testbed environment for collaborators to experiment and research the capabilities of 5G, while providing feedback to further develop and sustain the delivered networks within the testbed. So what that boilerplate statement really means is Rogers as a company can provide this connectivity, but we also learn through all the work that happens via this connectivity, all of the innovations that come as a result of it, and that's why Rogers as a partner provides engineering support, technical support, and connectivity enhancements through the feedback that we get from these partners. So I'm going to take a minute just to talk about the City of Calgary, their role in the 5G Discovery Zone. Mike kind of alluded to this as well, but setting vision and ensuring alignment with the city's goals. The city also coordinates efforts with the partners for economic development and drives progress to ensure the success of the program. That goes back to the application process that we're going to talk about in a minute here. Rogers' goal, of course, enabling the connectivity infrastructure within the zone. We offer engineering support and resources to assist participants in optimizing their technologies for the 5G capabilities, as well as fostering development and problem solving. So kind of what I just said, but written a lot better. Platform Calgary, they're collaborating, of course, with Rogers and the city to develop the challenge statements and circulate them to their network to attract participants. They also bring together the resources of Calgary's tech ecosystem to help startups launch and grow. And then, of course, Calgary Economic Development, they foster the collaboration, the networking, the innovation within the program, and engage with local businesses, startups, entrepreneurs to drive success into the program. So that's the team, as it were, that makes up the group of companies. And now we're going to talk about 5G. So the cool thing about the 5G Discovery Zone is it's Canada's first downtown 5G test environment. I'll show you exactly the footprint that we are operating in terms of the test environment in a few slides here. But as I mentioned, it enables innovators to develop, refine, and test new applications, leveraging existing 5G infrastructure while streamlining connectivity and testing environments. And then within the test environments, the collaborators can explore the potential of 5G, the connectivity that enhance their products and their services. And you've heard probably 5G a lot over the last little while. Why is it so important? Why is 5G being talked about so much? One thing you may not know is the G stands for generation. You guys might remember 4G, 3G. We were on 3G for a long time, LTE. One of the big differences with 5G is it operates on a completely different platform than all of those previous technologies. It reduces latency, which looking around the room, everybody probably understands. And it increases the ability for connectivity in high density locations. One thing Rogers likes to use as an example is Taylor Swift concerts. Rogers, of course, is a big sponsor for Taylor Swift's Eras Tour in Toronto and Vancouver. And talk about connectivity concerns when you have all of the Swifties trying to live stream and text and Instagram in a very confined location, which typically is surrounded by concrete in downtown buildings. That is kind of a practical application of the benefits of 5G if you compare it to a Taylor Swift concert. And I have two girls, so I have to mention Taylor Swift. We are, of course, Canada's largest and most reliable 5G network. The asterisk in there is it's always a competition in terms of connectivity within the telecos. Who has the most coverage? How is it defined? But currently, Canada's largest and most reliable 5G network. Reliable connectivity and fast mobile speeds is what I talked about, but the connectivity is one thing. What it enables is what everyone in the room and everyone online is probably most interested in. So I won't spend any more time talking about 5G. I will. 5G features and benefits. I touched on a lot of this in terms of my example there, but you can see density, capacity, responsiveness, uniformity, all things that a really good network are supposed to provide, and the resiliency to ensure that everybody gets to experience it equally. So going back, so that's 5G, setting the table, the discovery zone, the connectivity potential for entrepreneurs and businesses. But what are the goals of the 5G Discovery Zone and Innovation Center? Small and medium-sized entrepreneurs can leverage it for growth, for efficiency and commercialization, pilot their technologies in real-world environments, and we're going to talk about where some of the focuses are in terms of those environments. I think that's in the next slide, but there's also potential to attract investment, create job opportunities, and as a Calgarian myself, a lot of this goes back to things that will make our lives easier or safer or more streamlined, whether it's transportation or smart city initiatives. You want the city you live in to be tech forward, and I think that this is a great example of that. Researchers and academia, I'm going to go in that in a little bit more detail in a previous or a further slide. And I touched on being a Calgarian, going to school in this city, growing up in this city. It would be a very cool thing as a person in the tech industry coming into the industry, having a resource like this within the city that I work and live. Here's our borders. I talked about showing you a map. So it is a 10-block radius that we are piloting the 5G discovery zone in. You can see the UR here is the Andrew Davison building. The convention center is within that zone as well, talking back to the high density user experience, accessing the physical space. Platform Calgary, of course, is in there, the Central Library, City Hall. You kind of get a microcosm of a lot of different environments in order to pilot technology and get access to different areas. So that's the zone. Now, areas of focus, as I alluded to, transportation and mobility, public safety, climate and environment are kind of three pillars that the application process to get involved in the digital discovery zone harken back to. So areas of micromobility, special service vehicles, smart parking, a lot of the things that fall under that smart city kind of umbrella. Public safety, of course, crowd detection, emergency vehicle services, and then climate and environment. So traffic prioritization, preventative maintenance, lots of things actually in there that they have examples of. That also go into types of engagement. So connection and testing is one application process within the services that entrepreneurs and businesses can apply for. And then there's the Connect and Test Plus. And then there's themed challenges. And all of them carry different, I guess, areas of connectivity, different opportunities depending on where your business is at and what you're looking for. The theme challenges is also very cool, where a challenge will go out to the industry for a certain service or solution that we're looking to solve, and the winning ideas receive funding. It is free to apply and participate in the Discovery Zone application and acceptance process, where you can actually benefit in terms of financial support to further your company, your initiatives is within that theme challenges pillar. And that's all outlined in the application process, which I'll touch on as we progress here. Oh, it's the next one. So the application process, of course, is through the 5G Discovery Zone on calgary.ca. A lot of this stuff is pretty self-explanatory, so application information, company information, technology overview, and keep in mind kind of what we shared here in terms of those pillars and in tying back to the technology overview in driving forward those areas of focus and innovation, which is the next piece, areas of focus. Program of interest, and then just on the back end, the application process does go to a panel review with individuals from those 4 different groups that I mentioned on the offset. The reviews then select applicants based on how their application ties back to all those great things. So really having a focus on the 5G connectivity progressing a certain product, service, need, or solution within those pillars is key. And then I think finally, Enjoy the Wave Center is obviously first and foremost, but in terms of the connectivity that Rogers is providing, the 5G Discovery Zone, we wanted to afford anyone the opportunity to ask any questions that they might have, or further the application process, anything that anyone in the room might want to ask or share. Yeah, that's a great question, Jason. I'm not on the panel, so I haven't seen any type of application like that, but has anyone in the room applied? Not yet.
But it could be like a delivery robot, right? That wants to see, how does it leverage 5G to navigate public space better?
That's a great, and I don't know if anyone heard Jason, but a delivery robot is a example that Jason brought up. The connectivity that a autonomous vehicle of any sort, but deliveries, self-parking, self-driving cars, those types of things. An interesting one that we got involved in this summer with the city is something as simple as connected sprinkler systems for all of the city-owned planters. So something that you don't have to necessarily dispatch a bunch of people to walk around or drive around to water the planters that make, the city more vibrant and beautiful in the summer. It's you would think it's a small thing, but if you think of the people expense, the vehicle expense, all of the things that could be automated through not just moisture sensoring, but automated sprinklers, you get it at your home. Why can't you deliver it on a mass municipal scale? Any other things that pop into people's minds in terms of the use cases?
A lot of the people in the audience right now are city folks, so I think when it comes to the theme challenges and how to participate in that, I think that's more of a next phase, but how will that happen? Like, how do we find out about submitting, here's something we'd like to know more about?
Yeah, great question. So the theme challenges piece of the application process is driven, I believe, 4 times a year in different focus areas, as we kind of harken back to in terms of the pillars. The ideas and the possibilities are really endless, and I think that when it comes to the different groups within, say, the city and the priorities that each group would have, whether it's parking or we talked about Calgary Police Services and some of the connected worker technology, which doesn't just stop at law enforcement. There's also lots of safety automation that's going on. So fall protection, confined space monitoring, all of those types of wearables have lots of applications within those pillars, whether it's transportation or safety, hazardous material handling. Lots of cool things that we see come across our desk on the Rogers side that have connectivity requirements, have application requirements, but we don't have the technology to further them like the folks in this room would, or the entrepreneurs on the call. So maybe just some idea generating opportunities there, but like Jason mentioned, the possibilities really are endless with the right connectivity, and we start to think about less speeds and feeds now in the era that we are operating in, and more about what it enables, not how much you need, because the connections, the speed is there now. It's thinking about how to use it. So I think with that, if there's, oh yes, please.
Is this a completely separate network from what you already offer in your 5G commercially in the downtown? Is this completely separate?
Yeah, that's a great question. The question being whether this is a separate network than what is commercially available to anybody who, say, has a Rogers plan. And the answer is yes. So as part of the process, we provide SIM cards specific to this 5G Discovery network. So it allows for I guess more specific testing and access to a different layer of the 5G network, which is outside of what is commercially deployed right now. Because if you look at your phones, if you're a Rogers customer, you'll probably see 5G or 5G Plus sitting on the top of your screen right now. That's our commercial network that you get as a Rogers customer. What we would enable here is separate. It's still the same technology, but it is a specific SIM that would be utilized. So hopefully that answers your question. Yes, at the back.
In that case?
Sorry?
Are you referring to a P5G in that case? Private 5G?
Oh, private, yeah. So that's actually a really good question because we've even discussed it this week in terms of small cell deployments. Wouldn't it be cool if we, put in a like a private network service that could be tested within this facility? Also, even supplying radios or some of the technology that enables that service. When you start talking about a private network, you can do it in a couple ways. You can carve off spectrum that is specific to a certain user. We don't really operate that type of environment in say, a downtown or commercial location, but we can splice the spectrum so that users have access to a dedicated piece of the 5G network that certain hardware, certain SIMs kind of enable. So there's lots of possibilities, and when we talk about, I'll give you a great example, when you get into autonomous hauling, network connectivity is crucial. It is, life-saving, and so a lot of the stuff that Rogers does, say in the oil and gas or the mining sector, is that splicing or that private network allocation, where you go onto a customer site and your phone changes from Rogers to customer name because that spectrum has been allocated to that particular customer, which their autonomous vehicles then operate on, and they have full control and visibility, almost like a tiny little service provider. Or when you start splicing spectrum off, like you would for maybe a utility company who has disaster failover requirements or legislation that there's 100% uptime, all of those types of services is stuff that Rogers sells today. In the context of the 5G discovery zone, it's similar in the network that we are providing people access to, but it is not a full private network. It's a shared private network. Follow up?
We can create a separate network within the Rogers network.
Yes. Yes, that is correct. Yes, and it's similar to if everything is becoming wireless now, but if you think of a wireline network where we can carve off a wireline connection to a customer, the same is translating now to the wireless side of things, where we have the technology available to start to carve off a wireless piece of the spectrum, the same way that we would on a wireline. Great question. I think a couple minutes if there's any other questions in the room.
If a company is coming to you and using and partnering and getting advice from your engineers, any IP change over there, or everything stays with the company?
It's a great question. I do not know the answer to that, Jason. I was telling Mike before that as a sales guy. Do you know the answer, Cameron? It stays with the company. So, sorry, the question was the IP, would it stay with, say, Rogers and our engineering group, or would it transfer to the entrepreneur, the company, the innovator, follow them? And the answer is it would follow them. So.
Eliminates the fear of a company saying, hey, I want to test out my stuff on that 5G network, but I don't want to give up IP.
Yes, yeah, that's a great
question.
And
we get that same question with Living Labs, which is what I think this project is really like Living Labs on steroids, right? Because not only do you get to test your product, which we do all the time through Living Labs, so here out of the wave, but you also get that support from Rogers and the SIM card, which is really, really special.
Yeah, and then you can take something with you for sure. Yeah. Awesome. I think we're up against it. Thank you, everyone. Oh, Mike's going to close off for us, but thank you, everyone, for your time.
Thanks, Chris. Just wanted to say thanks to Chris. Encourage anyone who's interested to go to calgary.ca/5G Discovery Zone. There'll be more information on the theme challenges when they come out, which we're in the second phase right now. Connect and Test Plus will be coming out in the new year. It's a 2-year program. We're about 4 or 5 months into it now. So plenty of time to get your applications in and please check out the website if you're interested. Thanks, Chris.
All right, that's great. So, so Mike's from our local business and local economy team, and if you've got business questions or you're working at setting up a business or you're looking to leverage the city's digital service squad, right? So they help small companies set up point of sale businesses online and websites. Fair?
Yeah, increase their digital presence.
Increase their digital presence, right? Good stuff. And Rogers, Rogers, if you're at Canoe Meadows, if your kid is kayaking 3 days a week at Canoe Meadows in Kananaskis, Rogers is the only network that works out there. So thanks for that. All right, Chase, you're ready?
All right. Good afternoon, everyone. So for those that don't know me, my name is Chase Castelny. I am an IT project manager here with the City of Calgary with Smart Cities, also leading a lot of AR/VR initiatives that are currently going on. So I kind of want to start this by saying that I'm actually very fortunate in that who I work for. So I work with a great team and a great bunch of leaders that have given me the flexibility to really explore the idea of opportunities. And that has also allowed me to reach out to various other leaders and other business units and create really good collaborative partnerships with them to continue down this journey. And they've made the active decision to join me on this journey. And I'll be speaking to a little bit of that today. So I will start off with a video. I'm going to kind of preface it by saying it's not my video. It's actually Jason McEwen's. He is the head of VR at Lenovo, so I actually saw this video on LinkedIn. I reached out to him and he was kind enough to let me use it. And the reason why I wanted to use it was that it really encapsulates and mirrors my excitement for where this technology is today and where it's going to go in the future. So I will start that now and then we'll kind of get into a deep dive.
XR changes everything. How we connect, how we play, how we work. We've heard this. Where are we going to see it? Metaverse? How could it be dead? It hasn't even been born yet. It's around the corner, arriving tomorrow, not as soon as we'd like. Generative AI is the key. コミュニケーションの壁がない世界を想像してみてください。La distancia y el idioma ya no son obstáculos. XR and AI can achieve this. Connections that feel real, content that is personalized. When you wake up, your day is laid out before you. Checkboxes for the checkboxers, and an infinite canvas of opportunities for everyone. Go anywhere, learn anything, do it all. Generative AI has the power to turn anyone into a creative force. And just like the internet and smartphones before them, XR devices will unlock a new level of sharing our passions, hobbies, and dreams. Speaking worlds into existence is just around the corner. Don't believe me? Consider this. Just a few months ago, this video would not have been possible. These people are not real, no stock videos were used, all of it generated with text. This technology is moving at light speed, and this is the worst it will ever be. You don't believe this will impact all media? This will be how all content will be created on the fly just for you. And XR glasses will be the best way to consume it. The convergence of XR and generative AI and real-time engines will create a data-rich world that seamlessly integrates and assists with your daily life, or offers an escape when you need it. Yeah, wearable XR devices need to improve, but come on, do I need to go there? Faster, smaller, cheaper, better. That's just the normal path of all tech. History has shown that once an idea takes root, it evolves, making life more fulfilling, easier, and enjoyable. XR will get there. We always find a way. In the history of our world, technological advancement is undefeated. To get there, a full ecosystem of computing devices will be needed everywhere, generating, localizing, rendering, and serving a constant need for content that's literally in people's faces. This will deliver a legion of new products and services, new ways to interact with the world, new fortunes to be made, new experiences to share with your friends, both real and synthetic. When devices are simple, small, powerful, and your content is always ready and waiting, you'll use them. They'll be too important, too useful to ignore. XR will change how we see the world.
All right. Hopefully that video got you a bit hyped up. So I'm now going to get into some of the AR/VR projects here at the City of Calgary. Some of them are active pilots that we're currently working on. Some are still kind of in a conceptual stage of what could be coming in the future. The first one, augmented reality for emergency services. So being able to provide augmented reality solutions for folks like Calgary Police, City Fire, things for like wildfire, for example. VR training for safety code officers. So this was a recent initiative that we're leveraging our Innovation Through Procurement Challenge program with. So we're reaching out to a bunch of vendors external to the city to see if we can come up with a solution to provide our safety code officers really the ability to sit in an immersive environment and be able to inspect buildings against the Alberta and Canada building codes. VR for planning and development and local area planning and land use bylaws. So this is actually was my very first pilot that I did with VR in the city. This one should be wrapping up here at the end of the month. I will get into this one a little bit in more detail a little bit later in the presentation. AR for urban development and urban planning. So this again is one that's still kind of conceptual. So this one really surrounds providing the ability to give our urban development team and urban planners the ability to have like an AR headset, like a Magic Leap, go on site somewhere and actually drop a 3D model on the existing real world to see what those impacts are going to be in that kind of redevelopment community. Virtual reality training for anti-racism and discrimination. This one I'm hoping to hopefully move forward in the near future here. So this one I actually stumbled across, I think through the United States, where they really came up with a really great solution in giving the people the ability to basically be immersed in someone else's shoes, someone of another ethnicity, another gender, using it for workplace training to identify things like microaggressions or comments that shouldn't be said, inappropriate actions, body language, things like that. So it really gives the opportunity for people to be put in someone else's shoes, experience those situations, and be trained in how to properly deal with them moving forward. AR for corporate security. So this is kind of a two-sided coin. So in chatting with some of our corporate security folks, one of the challenges that they've certainly faced is when they kind of do patrols, for example, they really lose sight of a lot of things and a lot of data. So I want to hopefully provide them with a solution where they can continue on their patrols, have an AR headset, still see their camera feeds, still see things like glass break sensor data, alarm sensor data. They're also interested in potentially using VR for training as well. So having their corporate security folks be able to be trained in a virtual environment and be trained up in that method. Mixed reality for, I guess not even just mixed reality, but extended reality for water resources and underground assets. This could be kind of like a combo deal where we could leverage augmented reality headsets or mixed reality headsets for our water resource folks for when they go on site. They could see their hidden assets, like where their water pipes are currently laid. Are there electrical lines nearby? Has there been any kind of ground shift detection with IoT sensors? Has the pipe shifted 2 feet to the right, 2 feet to the left? That's something we need to be cognizant of when we kind of do these kind of things. And then NVIDIA Omniverse, I will touch on that here very shortly. So I want to get into a little bit of the benefits of augmented and virtual reality, especially around some of the training aspects. These stats came from the IBM Institute of Business Value. One of the big ones was a 200% boost in overall employee performance, which is quite significant. 45% reduction in errors, which is, again, is pretty significant when we want to reduce the costs associated with errors that happen in a job. This helps reduce those errors. 32% increase in productivity, and a 46% reduction in time to actually complete overall tasks. Going on, there's more benefits to VR training, of course. One of those is a 275% increase in being more confident to act on what you've learned with VR training, which is a massive leap in confidence for folks. It also reinforces those learning connections. So people that get trained in VR typically learn 4 times faster than a traditional classroom. It's more immersive. It develops muscle memory. People are emotionally connected to that material. For example, even like Chick-fil-A is using VR for their training to train people how to make milkshakes and hamburgers and develop that muscle memory and retention. So very valuable for that. 3.75 times more emotionally connected to the material versus a classroom or traditional e-learning, which again is a quite significant boost in connection to the material. And V-learners, which is just another term for folks that learn in VR, they're 4 times more focused during the training than they would be in like a classroom, and 1.5 times more focused than in the classroom and 4 times more focused than if it was e-learning. So being in that immersive environment, being connected to that material, having that emotion connection really amps up the focus of people when they're doing that kind of training. So now I'm going to start to get into some of the active pilots and what they're meant to accomplish. Again, like I said earlier, this was the very first one that I did for the city with planning and development and local area planning. So basically what we kind of situated here was that we worked with the local area planning team to take an existing community in Calgary. We developed a bunch of scenes using ArcGIS and Esri 360 to give the local area planners the ability to see the community as it is today, what it's going to look like in 3 years, 5 years, 10 years, 15 years, 20 years from now. So traditionally, they're relying on things like 2D blueprints, 2D maps. It's really hard to visualize new buildings that are coming up and redevelopments that are coming up. So this gives them a tool to their toolbox to be able to put on a VR headset and see how the community is going to change in 3D, in VR throughout the years, and really see what those potential impacts are going to be. So if we're converting a building from, say, a single story to a high rise, is that high rise going to put a public park in a shadow for the majority of the day? We don't want that to happen. Is it going to put someone's backyard or house in a shadow all day? We don't want that either. And that's really some of the things that are hard to determine from a two-dimensional perspective versus a 3D and virtual environment. Concept here, so VR training for Calgary Fire. I've seen a lot of instances of this throughout the United States, even some places in Canada where not Calgary Fire, I'm hoping to get Calgary Fire to use this, but firefighters have been using this in a multitude of ways to train in various scenarios, everything from floods to disaster emergencies, building collapses, door breaching, kind of scenarios. So there's a multitude of scenarios that we can train our firefighters in to be prepared for specific situations. And that helps cut down the cost of actually having to go to a physical site, find a physical site, get people to commute there, train people in the physical environment, the cost of the tools. It cuts down on that significantly. And that kind of takes me into the safety aspect. So this example here really highlights that training is supposed to be safe while providing a real-world simulation. In this example, a volunteer firefighter, and this was in Calgary, by the way, I'll make that very clear. A volunteer firefighter was actually doing a training exercise in person. It was during a drill, like an instructor gave her a compromised roofing tool. That tool ended up shooting her 3 feet backwards. She broke her wrist, and then she was out for a considerable amount of time because now she's injured. So these are the kind of situations that we could map out in a VR scenario. We could still give the door breaching tools or the roofing tools. They're still going to feel the same. They're going to act the same. You're still going to get that real life experience, but you're not going to get injured doing the safety in a virtual environment versus that risk doing it in a real life scenario. Now I'm going to dive a little bit into the NVIDIA Omniverse. So really what it is, it's a collection of software and tools that help developers and content creators build, create, and optimize content across a wide range of platforms. It's definitely through VR and XR. And that is still in beta right now with NVIDIA. I'm hoping to work with them in the future and be able to kind of experiment with it. But really where this comes into play is that we are able to leverage the cloud graphics processing cards in the cloud rather than us having to spend a large sum of money to get that kind of horsepower locally to generate the level of fidelity and graphics and detail that we want to generate. So if we can leverage those cloud GPUs to get a level of detail of scenarios similar to what you see here, where we can get full rasterization, get real life water reflection, glass reflection, colors, textures. The closer that we can get these scenarios to as close to indistinguishable from real life as we can, it also lowers that risk of some folks are sensitive to VR headsets, right? People get motion sickness, they get vertigo. I know there's people here that deal with that, for example. The reason why that happens is because when your eyes and brain kind of detect that something is a bit off, that's what kind of kicks that bodily response to say, oh, I feel queasy, I feel off, I'm kind of losing my balance. The closer that we can get to real life in these scenarios that your brain can't distinguish from it being kind of feeling off, the less risk you're going to have of having those kind of negative effects. So that's where NVIDIA Omniverse can potentially help us. Now, not really AR, VR related, but related to NVIDIA Omniverse, we can also train artificial intelligence with synthetic data with NVIDIA Omniverse. So where this comes in handy is we can do things, instead of having to take a bunch of cameras out to a road somewhere in the city of Calgary to train a model on potholes or road detection or road deficiencies, or detecting broken fences, for example, and we wanted to do that, we can 3D model and make digital twins of these roads, of these fences, of different assets, and we can train the AI model on that digital representation rather than us having to actually go out and find real-world examples to train this model on. So again, a lot of cost savings and time savings being able to train AI in this method rather than us having to go out and find different locations, try and train a model, and do it that way. Now I'll get a little bit into sort of the digital twins with CityEngine and Omniverse. So we've been working very closely with our partners in collaboration, analytics, and innovation to try and bolster our city. I don't know if any of you have seen our digital twin as it exists today, but it really is, you know, every building is in there, but it's just kind of the massing blocks, kind of grayscale. There's no color, texture, rendering quite yet. So we are looking at potentially exploring leveraging CityEngine of Omniverse to really bring that level of detail up to sort of what you see here, where you can start to see buildings in Calgary that look like the real life counterparts. We can leverage those buildings in a wide variety of VR, AR scenarios. Like I mentioned earlier, we can drop models on real life sites using AR. We could potentially use it for even things like notice postings for like planning and development. I don't know if anyone has ever seen the kind of notice posting signs that have been posted publicly that says, hey, something is coming up. We could do something like scan a QR code. That 3D building will pop up on someone's phone. They can see what that building is going to look like, and they can provide valuable feedback back to the city of what they like, what they don't like, changes they might want. So that's the benefit of being able to get our digital twin up to that level, are kind of components of that nature. We can also even walk inside buildings, outside of buildings, see how they're all designed internally and externally, and that also helps our planners, our urban planners, our planning and development team, local area planning, land use bylaw especially as well. So I want to also get into some of the key learnings that I've learned throughout my career trying to get AR and VR adopted into a corporation. I know maybe there's probably a lot of people here that are from external businesses, external corporations. You might have similar challenges trying to get new technology adopted. So I want to kind of touch on those from what I've learned in my experience. I'm going to kind of start from the top left, work my way down, and go from the top right, kind of work my way down. So the first one I really want to emphasize is that all of these tools are not meant to be replacements for people or jobs. These artificial intelligence, virtual reality, augmented reality, these are meant to empower our workers and empower people rather than take away. We want to upskill people, get them up to date with the technology rather than being left behind. And we really want to help them do their jobs better and more efficiently, cut down on costs. That's what these tools are meant for. These aren't meant to replace anybody. The next one, turning down ideas, is a way to help identify ideas that need further development. So this one is really important because a lot of people get discouraged if their idea gets turned down. I know I've been in those shoes in my past. Someone turns down your idea, you kind of get discouraged. But what I really want to emphasize is that it's not saying that an idea is bad. It's just saying that we need to sit down, have a further discussion. Let's refine that idea a bit further, what you're looking to accomplish. Let's come back to the table with those refinements, and then let's explore it from there on. So I really want to point out that if we turn down an idea, we're not saying no. It's just we need to have a little bit more discussion of how we can help you reach the vision that you're intending. Demos don't have to be big, but they have to resonate, and don't dismiss the power of storytelling. So, I mean, if I go back to my example with planning and development, with like my first pilot, I wanted to ensure with working with planning and development that the pilot that I'm proposing is directly related to the jobs that they do, the work that they do, the business that they do. I don't want to show anything that doesn't relate to how it's going to benefit the business that I'm proposing an idea to. So the demos don't have to be massive, they don't have to be perfect, but they do have to resonate with the business and what you're trying to get buy-in for. Create demos and leverage champions. They have to be lower than the decision makers. Now, why that is important is because really the end user and their experience is what really matters the most and how it's benefiting them, benefiting their job. If you can go to a bunch of people that are looking to create efficiencies, they don't know how, you show them a pilot, you show them a demo, and it really shows them how it can bring back those tangible benefits back to them. If they can see that, hey, it's going to help me do my job faster, better, more efficient, it's going to save on costs, it's going to get them excited, they're going to buy in, they're going to go to their leaders and say, we saw this really cool demo, this really cool tool, we want to try this, can you help us try this? And it just helps get that buy-in from starting kind of at the ground level and kind of working your way up to the decision makers that way. People are self-conscious about technology. This was something that I learned at a conference that I attended a couple years ago back in Houston. And they really made a kind of funny example, but basically they related it to that there's folks out there that are not exactly tech savvy, right? There's people that have never used VR before, they've never put a headset on, and when you ask them to do that, they almost feel like they're putting on a dunce cap in some way, that they feel self-conscious, that they want to look proficient immediately, they don't want to look like they're making a mistake or doing something they shouldn't. We need to be cognizant of those folks, and we want to really make sure that they feel comfortable. We don't want to make them feel self-conscious. We want that experience to be positive the first time that they try on a headset. And sometimes that does require for us to sit down and just really walk them through it, get them comfortable, and then that self-consciousness goes away. But that's a thing that we need to keep in mind in terms of equity. We're certainly going to deal with people that are highly technical and folks that aren't. And we need to really make sure that those people that aren't going to be self-conscious about using it. Which ties up into the top right here around focusing on the user experience. And that is really the most important thing that I want to kind of drill into. Is the user experience is the most important thing at the end of the day. People remember how they felt the first time they try anything. That first impression is everything. If you put on a VR AR headset and it's laggy, doesn't work, it crashes, makes you feel sick, that negative experience immediately impacts you the first time you do it, and you're not going to want to try it again, or you're going to be apprehensive to try it again, or you're going to maybe think that it's not ready for prime time to be used in certain situations. So when you're doing demos and pilots, you really need to focus on that user experience and try to mitigate a lot of those negative aspects as much as you can, because you're not going to get buy-in unless it's a positive experience. 3D scanning with iPhones is viable for small scale. We've been experimenting with that here. I can actually show that demo to you at the end of the day when we're doing demos in the VR room in the back. But where I certainly leveraged this was with Matterport and the iPhone. So I went out to Olympic Plaza, and we wanted to kind of preserve its heritage, preserve its history as redevelopments are kind of going on. So I went out there with my iPhone. I took about 8,000 photos by hand. Our field serving folks that are sitting in the back there, you can see that demo later. They came out with their drone. They took some pictures. They took out their laser terrestrial scanner, took some scans. And I went out there with my iPhone as well to do like a 360 Matterport scan. I think I did about 300 of them, walking every 3 feet. But it turned out really well. Like you can walk through the whole Olympic Plaza in a 360 environment. You can see it in VR. You can see it in your laptop, any device, but it really preserves how that Olympic Plaza looked at that moment and given in time. We're also working with our partners in collaboration, analytics, and innovation to try and get a digital twin generated of that plaza using Unreal Engine or Unity, and using all those photos, all those scan data, get a 3D digital twin made up, and then you can actually walk through the Olympic Plaza as it was that day in VR or AR and experience it kind of in a historical sense to preserve it. You have to get the headset on people and then work up to the decision makers. Like I said, you have to build excitement from the bottom up. So really, at the end of the day, you have to get the headset on people, because depending on people's learning styles, some people are more visual, some people are more auditory. You really need to get the headset on people for them to really understand what you're trying to do, what the benefits are, how it helps them in benefits, because just trying to explain it from a PowerPoint is super difficult, which is why we have the VR room and a bunch of headsets sitting back there, so you folks can go and check it out after. But you really need to experience it for yourself to understand the benefits that come with it. And it's not something that you can explain in 2 dimensions. You really have to try it, experience it, and see those benefits that kind of come back. Failure is a good way to learn, and it's iterative, and not all projects are successful, and failure is just as good. So that was something that took me a while to learn in my career, for sure. But failure is not the be-all and end-all. Projects aren't going to be perfect out the door. Pilots aren't going to be perfect out the door. Things are going to fail, but it's not the end of that project. We can learn from our mistakes, make some tweaks, make adjustments, reiterate, reapproach it, spin up that project again, see if it works, and just continue to iterate and get better. Perfection is hard to achieve. It's almost impossible in a lot of cases, but you can get pretty close as long as you consider that you can fail, you can reiterate, and continue to improve and get better as you move along, right? So here what you see is, I guess you could call it, the adoption curve when it comes to technology, right? So this really identifies a lot of the challenges that it comes to adopting new technology. So if you look on the far left, you'll see kind of the area before what's called the chasm of tech enthusiasts that are innovators, early adopters, and that group is always super stoked and super excited on wanting to immediately grasp onto new technology, adopt it, get it implemented immediately. But the problem with that is that you don't know where that technology is going to go. You don't know if it's going to be like Betamax and it's going to be around for a little bit, then disappear. You don't know if it's going to be kicking around for 20 or 30 years, right? And where companies have struggled by adopting too early, I mean, I guess I might be aging myself here, but I don't know if any one of you remember like the Virtual Boy for Nintendo, maybe back in the 90s. So Nintendo dumped about $30 million on promotional campaign materials. They really touted this system as like virtual reality for video gaming. At the end of the day, you tried on the headset, it was bright red on a black screen, so it hurt your eyes, it made people feel sick, the graphics weren't immersive. That product failed after 1 year. They sold about 700,000 units, and they lost that kind of $25 million investment. And that's the risk of adopting too early, and you see that with a lot of startup companies as well. They jump on board too early, and there's a risk of losing that initial investment on adopting too early. The flip side of the coin is that you could also fall on the right side and wait too long, and you kind of stagnate, right? And the problem with that is that if you wait too long and you stagnate, and then you try to kind of play catch up, you're always going to be kind of spinning your wheels and trying to catch up, because technology is evolving and moving so fast that by the time that you get to where someone else was, where they hit that early adoption, early majority kind of phase, you're always going to be behind, right, by stagnating too long. So what we've done here is that we've basically successfully kind of leapt that chasm, and we're kind of sitting in that sweet spot of the early majorities. So AR and VR, as you well know, I mean, people have MetaQuest 3s in their homes. They're using it for games. They're using it for interior decorating designs. They're mapping out their homes. They're doing video calls, watching movies. Like I said, Chick-fil-A is using it for their company training. Boeing and Lockheed Martin are using it. So we've reached kind of that sweet spot with adoption of AR and VR in that it's not at its full mature and its ultimate capability of where it's going to go, but we're early enough that it's widely adopted enough that we can jump into the sweet spot and start to see how it's going to benefit our businesses, our partners, and residents of Calgary, right? So one more thing. So I want to touch a little bit on augmented reality for emergency services. So we do have a Magic Leap, and I know in a lot of cases when you see kind of demos in a two-dimensional state, you think, this was photoshopped, this was CGI. I've got a Magic Leap in the back in the VR room that I can spin up. I'm going to spin up this wildfire example kind of at the end of the day after our next speaker goes. And I'll let you walk through this kind of wildfire example in augmented reality and some other augmented reality demos that I have. But I can promise you that it looks better than what you see on the screen, with no jokes. So that's all I've got. So that is my presentation on AR and VR in the city. And I will pass it to, I guess, back to Jason, not Dave, right? Okay.
Just before, thank you. That was awesome. I think just before Dave comes up, I just wanted to say what an exceptional member of our experimentation team that Chase is. I think what you're seeing is that passion for VR, that passion for exploring what's next, and then that commitment from the Wave to invest in those assets that make experimentation much easier. So whether you're fire or your parks, you don't have to make this $300,000 or $400,000 investment on your own to come and see if VR is going to help you train people how to ride lawnmowers, right? So you can leverage the assets that are here in the Wave. We're here to make experimentation easier, and we're here to add that support and some of that industry knowledge, again, that Chase has brought to our team. So thank you very much, Chase. And yeah, with that, I'll bring up Dave. And Dave, I don't know if you noticed, but Chase, you talked about the synthetic data, right? And we have another amazing experimenter here, Saksham Puri, our co-op student. He was working on a parks project. Sorry, Dave. He was working on a parks project teaching an AI bot to recognize broken fences. So we started off, we did a little bit of drone work. It was very slow, really slow actually, and it took a lot of people because you have a drone driver, a pilot, sorry. I'm looking at their survey team back there. Pilots, and then you have a spotter, and then you have, another safety person, and then you have Saksham and I out in the field. That's really intensive to instead of just walking the fence. So then we hooked up a camera on a cargo bike, and Saksham rode a cargo bike around parks for a while. But then, we got weird shadows. So then he took went to a warehouse that had fencing in it. Saksham's just over there. And hi, Saksham. So then he created synthetic data, actually, and thousands of kilometers of synthetic data to train the spot to recognize holes in fences. It was awesome. And at some point, Saksham, you'll see his report. He's going to publish some work with Nan's team just on how he trained the spot and how we're using it for city stuff. And with that, Dave, another, with all the cool stuff we got going on here, we've already talked lots about how we're we're using data, but we have to stay on side of data. So I'll pass it to you.
Thank you. Thanks, everybody. I hope you're enjoying your time here at the Wave Center. It's pretty cool. Everybody hear me? Okay. Thanks for coming to see a presentation on enterprise data and data in general. I've never used a slide that looks like this before, in case you're thinking the whole presentation is going to be like this. I'm pretty good at the written material, but not very creative. So wrapped up the presentation, I asked the AI to create an opening slide for me. And this is what it gave me. So I kind of thought, I can't use that. That doesn't look that professional. But then I thought, you know what? It's kind of funny. I think I'll keep it. Then it dawned on me, did the AI go through my entire presentation and it said, this represents my work. So I love the AI, but sometimes I think it's messing with me. Okay, so we're talking data as a strategic asset. when we move into data strategy for the city is really tapping into the potential of the data to achieve the city's goals and objectives and so on and so forth. When you're talking strategy in general, you're trying to win at something. And so if you're an airline, you may be looking to win at trying to get market share. Your strategy is to come up with the lowest cost, trying to appeal to cost-conscious customers. And that's how you're going to win, to get market share. The city is different. The city focuses more on essential services and equality across the population. And really, the city's win is about providing value. And so this data strategy underpins so many of the other strategies that deliver on that value, those outcomes. And the data there is a critical layer. So when we're talking data strategy, you can see all these items, and there's many more. We're talking governance, we're talking stewardship, privacy, security. All these things are important aspects of the data strategy. Now, you might be asking, well, what's changed, right? Haven't we had strategy all along? We have, and there's been pockets of it, but with the explosion of data and data types and like the things you're seeing here today, you have to have a more targeted data strategy, more encompassing data strategy to be able to handle these volumes of data. The city is also under more pressure than ever to be able to have answers to the questions they're being asked. And when you're looking at some of these questions, you're looking across the whole organization and all this data and how to bring it together to answer those questions. So what's next? Well, the strategy, our approach is to take a minimum viable approach. And really what we're talking about there, you could word it as the need to have versus the nice to have. I tend to focus more on where are we in the organization? What does this area need compared to this area? Where are they in terms of business readiness, data readiness, people readiness? That's how you can target your resources to maximize the value, because like everybody keeps talking about, we don't have infinite resources. So brushstrokes across the whole organization sometimes don't work. You really want to target specific business areas when it's applicable for what they need specifically. So talk data management. Data management could be a whole presentation on its own. Data management for the data strategy is at the core. It's the heart of it. And around data management are a whole bunch of other things that we'll get into, all these components or framework components, whatever you want to call them. Data management, at a high level, what you want to realize is that data management is all the interactions of your data. It is the pipelines, the security, everything from the whole life cycle, from creation to deletion. And one of the important things to understand about data management is that it drives other things, but these other things also feed back to it. So if you look at an example like security, it's going to drive security and how security is run, but changes in the world, changes in how security is handled, feed back and update data management. I love these AI images that I picked. A lot of these are the AI. So moving past data management, data governance. Okay. Data governance is all the things you see here and more. You know, we're talking business processes, budget funding, procurements, architecture. So governance could be cumbersome, but the way to handle governance best and to make it light and agile is to have the right membership for your governance, but also have a group with the right membership and skills that comes together, which this strategy is pulling together, so that the information and the recommendations going to governance are what they need to hear. This is how you get the decisions made quickly. You may not like the decisions, but you'll get them made quickly. And you'll get the approvals you need so that your business can move along effectively. Governance does not have to be heavy. And this strategy lays it out so that it's actually quite lightweight. Security, access, privacy, legal, all these great things. So first of all, I'm going to say the strategy is not starting these. These have been in place for a long time and they're well managed. But these security issues and access with all this data we talked about, with everything changing, they're bigger issues than ever, or bigger areas of focus, I should say, not issues than they've ever been. And they do look after policy changes and legislative requirements and the like, and data security acts and so on. But when you're looking at the data, and especially the new data coming in, citizens have a right to expect that their data is being secured, it's being managed properly, it's being ethically used. They have questions such as, Where is the data? Who's accessing it? Is it being used for the purpose it was intended? Is somebody else giving access to data? We refer to that as access by proxy or permission by proxy, which we want to avoid. And having a strategy that brings these groups together with the other specialty areas in the organization addresses those concerns, and it helps with the security. Technology plays a big factor into this. The technology out now is able to do more than it ever could. You can have what's referred to as zero trust modeling. Zero trust sounds a bit harsh, but it secures that data layer right from the ground up, right when it's created. And it just gives an extra layer of protection. It can mask data, it can secure data, and identify it before you accidentally release it or share it. It gives a whole set of capabilities and advancements we haven't had before. And that works in conjunction with all these security, access, and privacy and legal. One of the areas I'd really like to talk about quickly is new data. So when you're talking about new data, especially sensitive data, you can't just acquire it. There's a lot to that, right? If you're, I guess sometimes it does happen, but you really want to be careful how you're collecting new data. You need to identify it, find out if you're allowed to access it. If you are, do you have it? Where can you access it? How are you going to store it? What are the security requirements, retention? All these things are at play. So you want to be very, very careful, and you need a strategy in place to bring everything together in order to address data from the beginning. And security layers on with the other solutions. You've seen things like analytics, AI, they all have additional security layers. But if you can support those other strategies by instilling security right from the ground up, you're going to be more protected. Data quality. All right. Everybody wants data quality, whether you're talking completeness or accuracy. A lot of it comes down to how it's collected. People need to be able to trust that the data that they're accessing is what they should be accessing. They can trust that it's accurate, accessible, and complete. And so this really ties into the entire data lifecycle from the time it's created until the data is deleted. Quality ties into a lot of how it's collected. And so you want a collection methodology that best describes how the data is going to be collected, ensures the most complete way to collect it, and deals with the systems that are in play. There's a lot of systems out there, a lot of applications that collect data, and you want to have a close relationship with the vendors and how these systems are evolving in their data collection. One thing to be careful with, and you've probably heard of data bias, and data bias is a real thing. And depending on how it's collected, you could have people that reach the wrong decisions or they encounter biased data because it's too narrow of a demographic. They're picking from a skill set because that's all they have to pick from, and so they're working with what they have. The data is old, and it may not reveal the complete picture. So you want to be very careful about data bias, and you want to be able to examine what data you're looking at and see if it is as complete and comprehensive as you need to be. A lesser used term is data harm. And if you haven't heard of data harm is when if the data is not of high quality, you can reach a conclusion from it. And then from that data, you can reach another conclusion. As you reach these conclusions, they build on one another and they compound. And so you want to be very careful that one wrong conclusion isn't leading to another and leading to another, because that's data harm, and it can steer you absolutely in the wrong direction. This strategy focuses a lot on data rationalization. And if you haven't talked about or heard of data rationalization, it really, I'll use an example. If you're in an organization like ours and many other organizations, you have areas, and totally normal, they've evolved, and they have a system over here and a system over here, and these systems do the same kind of things, and they have similar data. If you can rationalize that data, bring it together, and maybe data here that isn't complete, not complete here, you can bring it together, you can get a more complete picture and higher quality data. The other thing data rationalization does is it leads to authoritative sources of data. So when you're concerned about data not being reliable, you're getting different results depending on what you're running, having authoritative sources of data is critical. And this strategy puts a tremendous amount of focus on the methodology in place for collecting and updating that data. There are data sets out there all over the place, but you want to make sure that you know your source of data and that's being updated appropriately. Data processes, what a big topic that is. Data is tied to process. Your processes, your business processes generate data. If you need to change your data, you have to update your data processes. Data process or business process change is not easy. And this strategy puts forward and builds on the skill sets for helping businesses review the process and modify them to get higher quality and more complete data. One thing I say it quite a bit, and every time I say it, people seem to buy into it, is that an organization just knowing what data it has and what it doesn't have is a big deal. And that may sound like it's not, but it is huge just to know what you have and what you don't have. Yes? Oh, sorry. Sorry, folks. Not used to having mic. What else? Data stewardship and, or data literacy and stewardship. So on the Gartner slide here, it outlines driving organizational awareness. You have your vision and you roll in a data literacy program. This strategy rolls in a data literacy program, and it's critical for uplifting your organization to a level of knowledge where they are aware of the ethical considerations around data, they understand the privacy, they understand where the data is, and it opens up so many avenues to being able to access and share that data. Now, a data literacy program can also target or focus on certain individuals that are more deeply into data. It creates a community. It allows them to get the training they need. It's part of organizational change management, which is something else we're building on. Together, data literacy with communications and training fall under organizational change management, and that's absolutely vital for the data to be opened up and shared across the organization. Data stewardship, what an incredible, important role here. And you can see at the bottom it says function as data quality ambassadors, and that's very, very true. Data stewards are the experts. They are the go-to people. They know the data. They know the history of the data. They know who's who. They know its shortcomings, what it's being used for. They know the people. They are true experts. And when you establish them and train them, and you have backups for them, and you ensure the continuity, the data steward community, probably one of your best ways to unlock the data for your organization and really tap into the power of it. One area where organizations can fall down is where they don't put the training into this, they don't identify. So what ends up happening is somebody with the knowledge retires, the next person comes in, 6 months in, they find out, I'm the data steward. And what happens is when they ask what they're doing, oh, you're responsible for protecting the data, they retract, and they don't want to get in trouble, they don't want to make mistakes, so they retract. And that's the last thing we want. So we want these people trained, we want them being able to talk, interact with governance, and form that community to really tap into the power of this data. Technology, well, no surprise that technology is a big part of this. We've been using technology for managing data in different ways since there's been data. We have technology for storage, for processing it, for accessing it. We try to use what we currently have. Sometimes technology has been rebranded, but it's really still the same thing in some cases. And we have it and we leverage it because that's where the value is. We don't have to do upskilling or try to replace it when it's not necessary. Now, there is some pretty incredible technology out there, new technology to bring data together, the vast amounts of data, the new types of data, and as was mentioned earlier, to secure the data. So this technology is something we do want to leverage. We want to manage it carefully and securely, but there's so much out there, and it really takes upskilling and investment in it. And this is it. You can see how much is involved in technology. Now, how do you talk technology these days without talking AI? And so I like to call it data for AI and AI for data. So this is, when you're talking data for AI, it comes back to that quality that AI needs, but it also focuses on real time, the need for real time. bringing that data together, static snapshots are not near as good when the data is coming in. This image is AI's representation of telematics. So as this data is brought together and it's needed for real time, there's also the modeling. AI can work with data, but if you can model it, there's a lot better people talk about modeling than me, but if you can model the data for AI and other emerging technologies, you're really going to tap into the power. Data, as the AI folks will say, is the lifeblood of AI. It's a bit cliche, but that's how they word it. AI for data. This is my favorite topic. In this example, you can see that there's a scratched up plate. The AI has scanned it, it's gathered information, it's saying that's possibly a motor or a pump, and it has the model number to go and search and find out what extra information on this. Could a person do this? Yes. Could a person do as fast? No. Or as accurate? No. So I love examples of where AI is able to take what a person can do, but the volume of work is not feasible, and able to act on that volume of work. Another example we have is where you grab data from scanned records, from formal records, from files. The data is, you've grabbed what you wanted at the time, and that makes sense because you don't want to grab everything. But years later, you find out you need another piece of that data. Trying to go through all those records can be very difficult. If you use the AI, you can scan those records on volume, grab the information you need, execute on the work you want to do, and also complete the data. Outcomes. Okay. I love talking about outcomes. If you look at the history of data, how it's been managed, you had data first. You were doing system startup. You had your data, and you want more data. Then you got more data, and you had the tools to work with that data. And then you got too much data, and the attitude was, let's clean up that data. And then what that moved into, that didn't work all too well. So then what you moved into from there was, about the mid-2010s, it was, well, let's access that percentage of data that's useful. And even that wasn't too successful. Nowadays, it's about outcomes. It's about quickly running exercises, identifying that most important data you need, avoiding sifting through those massive volumes of data, and finding out these data points that become common in importance across your organization, across your business area, and identifying that and getting to exactly what you need very quickly. While all this is being built, your business, the ones that are knocking on the table to get things, you're able to access the data you're really looking for. And this is the outcome planning. Data-driven stories and decisions. Okay. Data-driven, some people ask, well, what does that really mean? Well, you have your intuition, you have your gut feeling, you have your experience, but you want to back it up with data, and that's data-driven. Whether you're going into a boardroom to pitch an idea or ask for funding, you want to make sure you have the data for data-driven decision-making. And for the stories, data-driven stories across the organization, you need to have all that data unlocked, all that data brought together by a strategy, and then something like the AI over it. Be able to pull all that data together and give you the insights to tell these data-driven stories. Finally, data culture underpins everything. Data culture is great. There's all kinds of data cultures, and that's excellent. What you want your data cultures to have in common is that they all view data as an asset, preferably a strategic asset. If they do, you're going to get the investment that you're looking for, you're going to get the support you need, and you're going to treat it just like anything else, a bridge, a parkway, a train. It is a critical asset and needs to be managed as such. And with that said, I can't think of a better place for data culture to advance than here at the Wave Center. So with that, I'll say thank you. And if you have any questions, I'm happy to take them.
All right, folks, so that is the last presenter of the day. So you're free to